In the deepest corners of theoretical physics lies a journey so terrifying that even Einstein himself recoiled from its implications. We've all dreamed of traveling at the speed of light. Imagine the places we could go, the time we could save, the universe we could explore. But what if I told you that Einstein spent sleepless nights haunted by what you would actually experience on such a journey? What if the speed of light isn't humanity's greatest opportunity, but rather nature's most merciful protection? The question that tormented the greatest mind of the 20th century wasn't whether we could reach light speed, it was whether we should ever want to. Join me as we embark on the most disturbing thought experiment in physics, following Einstein's own mathematical breadcrumbs into a realm where time betrays you, space contracts into nothingness, and reality itself begins to dissolve. Before we step into Einstein's nightmare, I'm curious, where are you watching from right now? And what time is it in your corner of the world? Drop your location and local time in the comments. It's fascinating to think that no matter when or where you're watching this, we're all bound by the same cosmic speed limit that Einstein discovered. Albert Einstein was 26 years old when he published his special theory of relativity in 1905. But the thought experiment that would eventually terrify him began much earlier, during his teenage years in Switzerland. Picture young Einstein walking through the streets of Aarau, gazing up at the afternoon sun and asking himself a deceptively simple question: what would I see if I could ride alongside a beam of light? It was the kind of question that only a mind destined for greatness would dare to ask. Throughout human history, we've been obsessed with speed. We've tamed horses, built steam engines, conquered the skies, and hurled ourselves into space, each breakthrough bringing us closer to our ultimate fantasy of instantaneous travel. The speed of light represented the final frontier, the ultimate velocity that would make us masters of space and time itself. In Einstein's era, light was already known to travel at an incomprehensible 186,282 miles per second. To put this in perspective, light can circle the Earth's equator more than 7 times in a single second. It can travel from the Earth to the Moon in just 1.3 seconds and reach the Sun in about 8 minutes. This wasn't just fast, this was the very definition of speed itself, the cosmic speed limit that seemed to govern everything in the universe. But Einstein's teenage curiosity wasn't satisfied with simply marveling at light's velocity. He wanted to understand what the universe would look like from light's perspective. What would happen to space and time if you could somehow accelerate yourself to match light's incredible pace? Would you see the universe frozen in time? Would distances shrink to nothing? Would you become one with the electromagnetic waves themselves? As Einstein matured from a curious teenager into a revolutionary physicist, this thought experiment evolved from innocent wonder into something far more disturbing. He began to realize that his innocent question was leading him toward conclusions that challenged everything humanity believed about the nature of reality. The mathematics he was developing didn't just describe faster travel, they revealed that approaching the speed of light would fundamentally transform the traveler's relationship with existence itself. What started as a dream of ultimate freedom was becoming a vision of ultimate isolation. Einstein began to understand that light speed wouldn't liberate humanity from the constraints of space and time. It would trap us in a nightmarish realm where the very concepts that make life meaningful would cease to exist. The young physicist, who had dreamed of riding alongside light beams, was growing into a man who would spend decades warning humanity about what such a journey would actually entail. This wasn't just theoretical physics anymore. This was Einstein beginning to glimpse the cosmic horror that lay hidden within his own equations. The first hint that nature might be actively protecting us from light speed came through Einstein's most famous equation, though not the one you're thinking of. While E=mc theory captures the public imagination, it was actually a different formula that revealed the universe's built-in safeguards against ultimate speed. The equation that haunted Einstein was deceptively simple. As any object with mass approaches the speed of light, the energy required to accelerate it further approaches infinity. This isn't just a practical limitation, it's a mathematical impossibility. Infinity isn't just a very large number, it's a concept that breaks mathematics itself. Let me put this in terms that reveal just how absolute this barrier is. Imagine you're driving a car, and you want to go twice as fast. You need roughly 4 times the energy. Want to go 3 times as fast? You need 9 times the energy. This is normal, manageable physics. But as you approach light speed, this relationship becomes violently exponential. At 90% the speed of light, you'd need about 2.3 times the energy that Newton's laws would predict. Difficult, but conceivable. At 99% light speed, you'd need about 7 times more energy, getting expensive, but still within the realm of possibility for advanced civilizations. At 99.9% light speed, you'd need about 22 times more energy. Now we're talking about the energy output of stars. But here's where the mathematics becomes genuinely terrifying. At 99.99% light speed, you'd need about 71 times more energy. At 99.99%, you'd need 224 times more. The numbers don't just grow, they explode exponentially, racing toward infinity with each additional decimal place. Einstein realized that this wasn't just an engineering problem, waiting for better technology to solve. This was the universe itself saying no. The mathematical structure of reality contains what physicists now call a hard limit, a boundary that cannot be crossed, hard regardless of how advanced our technology becomes or how much energy we can harness. Hard we can harness. Energy we can harness. Even if you could somehow capture and convert the entire mass energy of the observable universe, every star, every planet, every atom, it still wouldn't be enough to accelerate a single proton to exactly the speed of light. The universe simply doesn't contain enough energy to break its own speed limit. This revelation disturbed Einstein on a profound level. He was discovering that nature wasn't just difficult to overcome, it was mathematically impossible to overcome. The universe appeared to be designed with built-in protections, as if the very structure of space and time was conspiring to prevent anyone from reaching light speed. But Einstein's growing unease wasn't just about the impossibility of light speed travel, it was about what the mathematics implied. If the universe was so violently opposed to letting anything reach light speed, what did that suggest about what would happen if something somehow could? Einstein's true genius lay not in accepting the impossibility of light speed, but in asking the next logical question. If we can't reach exactly the speed of light, what happens as we get arbitrarily close? This question would lead him into mathematical territory, so strange that he would spend the rest of his life warning people about its implications. When physicists talk about approaching light speed, they're not talking about getting close in the way you might approach a destination in your car. They're talking about getting asymptotically close, meaning you can always get closer, but the final gap can never be closed. It's like trying to reach the horizon. No matter how far you travel, it always remains the same distance away. But here's what Einstein discovered that chilled him to the bone. Even though you can never quite reach light speed, the effects of approaching it don't gradually intensify. They explode exponentially. The difference between traveling at 99% light speed and 99.9% light speed isn't just academic. It's the difference between experiencing mild relativistic effects and entering a realm where the fundamental nature of reality begins to break down. At 99% light speed, time would slow down by a factor of about 7, strange, but manageable. Your journey to a star 10 light years away would take about 10 years from Earth's perspective, but only about 1.4 years from your perspective. Weird, but still comprehensible. At 99.9% light speed, time dilation jumps to a factor of about 22. That same 10-year journey would feel like just 5 months to you. At 99.9% light speed, the time dilation factor becomes 71. The journey would feel like less than 2 months. The universe outside your spacecraft would appear to be racing through time at an incredible pace. But Einstein realized that these numbers, as extreme as they seem, only hint at the true horror. At 99.999% light speed, the time dilation factor jumps to 224. At 99.999%, it becomes 707. The numbers don't just increase, they rocket toward infinity with each additional decimal place of accuracy. This exponential escalation revealed something that deeply disturbed Einstein. There's no such thing as gently approaching light speed. The relativistic effects don't gradually intensify. They explode suddenly and violently. One moment you're experiencing strange but manageable time dilation, and with just a tiny increase in velocity, you're catapulted into a realm where minutes for you become centuries for the outside universe. Einstein began to realize that this exponential escalation wasn't a bug in the mathematics. It was a feature. The universe seemed designed to make the final approach to light speed not just difficult, but psychologically unbearable, as if nature was saying, you can get close enough to glimpse what light speed would be like, but the experience will be so horrifying that you'll never want to get closer. This was Einstein's first real glimpse into what he would later call the cosmic speed limit's protective purpose. The mathematics weren't just describing physical limitations. They were revealing a universe that seemed designed to protect conscious beings from experiencing something that would fundamentally destroy their relationship with reality. But the exponential approach to light speed was just the beginning of Einstein's nightmare. The real horror lay in understanding what you would actually experience during this mathematical journey toward infinity. And that's where Einstein's thought experiment transformed from curious physics into existential terror. As we'll discover, the universe's violent resistance to light-speed travel isn't cruel. It's merciful, because what awaits at the end of that exponential curve isn't transcendence or liberation. It's the complete dissolution of everything that makes conscious experience possible. In 1907, 2 years after publishing his special theory of relativity, Einstein received a letter that would haunt him for decades. A colleague had worked through the mathematical implications of time dilation and reached a conclusion that even Einstein found disturbing at high speeds. Time doesn't just slow down, it becomes fundamentally unreliable as a measure of shared human experience. This was Einstein's first encounter with what he would privately call time's betrayal, the realization that the one thing humans had always counted on, as universal and absolute, could become a source of profound isolation and existential horror. To understand why this disturbed Einstein so deeply, imagine you're embarking on humanity's first near-light speed journey. Your destination is Proxima Centauri, our nearest stellar neighbor at 4.2 light-years away. You'll be traveling at 99% the speed of light, and according to your calculations, the journey should take just over 4 years from Earth's perspective. But here's what Einstein realized would actually happen. As your spacecraft accelerates toward light speed, time dilation kicks in with a vengeance. At 99% light speed, time slows down by a factor of about 7. This means that while 4.3 years pass on Earth, you experience only about 7 months of subjective time. Already, the shared timeline that connects you to humanity begins to fracture. But the real horror begins when you look out your window. Due to time dilation, you're not just experiencing time differently, you're watching the universe age in fast forward. Stars that would normally evolve over millions of years appear to go through their entire life cycles in what feels like months or weeks. You watch civilizations rise and fall, mountain ranges form and erode, entire species evolve and go extinct, all compressed into your shortened journey time. Into D. Einstein realized that this wasn't just a curious side effect of high-speed travel, it was a fundamental assault on human consciousness. We're creatures who find meaning through shared experience, through the knowledge that we exist in the same temporal framework as our loved ones, our communities, our species. Time dilation doesn't just change your relationship with time, it severs your connection to the very concept of shared human experience. The mathematics revealed something even more disturbing. The effect isn't symmetrical. While you experience months, decades pass on Earth. Your friends age into elderly people. Your children grow up, have children of their own, and possibly grow old themselves. Entire generations of human history unfold, while you experience what feels like a brief journey. This asymmetry troubled Einstein because it violated one of our deepest assumptions about fairness and reciprocity in the universe. In normal experience, if you go on a journey, Time passes equally for you and for those you leave behind. You might be separated by distance, but you're united by the shared progression of time. Relativistic travel shatters this unity. Einstein spent countless hours working through the psychological implications of this temporal isolation. He imagined returning to Earth after what felt like a short journey, only to find that everyone you knew was dead, that the world had changed beyond recognition, that the very language and culture you remembered existed only in historical records. You would become a living fossil, a relic from a past that everyone else had moved beyond. But the mathematical horror doesn't stop there. Einstein realized that as you approach ever closer to light speed, time dilation doesn't just intensify, it explodes exponentially. At 99.9% light speed, time slows by a factor of 22. At 99.99%, it's a factor of 71. At 99.99%, it becomes 224. The numbers race toward infinity, meaning that even tiny increases in speed, near light velocity, create enormous differences in time experience. This exponential escalation revealed to Einstein that approaching light speed wasn't like climbing a mountain, where each step brings predictable progress. It was like falling into a temporal abyss, where each increment of speed catapults you further away from shared human time. The universe seemed designed to make the final approach to light speed not just physically impossible, but psychologically unbearable. Einstein began to see time dilation not as an interesting theoretical prediction, but as a cosmic warning. The mathematics were telling him that consciousness and near-light speed travel were fundamentally incompatible. The very experience that makes us human, our sense of existing in a shared temporal reality with other conscious beings, would be the first casualty of our quest for ultimate speed. This realization marked the beginning of Einstein's lifelong ambivalence about his own discoveries. He had revealed the mathematical structure of space-time, but in doing so, he had also revealed that this structure contained built-in protections against experiences that would destroy the foundations of conscious existence. The teenager who had dreamed of riding alongside light beams was becoming a man who understood that such a journey would mean riding away from humanity itself, watching from a temporal prison, as everyone and everything you had ever known aged into dust while you remained trapped in your own accelerated reference frame. And this was just the beginning of time's betrayal. As we'll see, the temporal distortions of near-light speed travel create paradoxes that challenge not just human psychology, but the very logical structure of cause and effect that makes rational thought possible. The twin paradox is usually presented in textbooks as an elegant demonstration of time dilation's counterintuitive effects. One twin travels to a distant star at high speed, while the other remains on Earth. When the traveling twin returns, they find their earthbound sibling has aged more rapidly. It's typically framed as a fascinating quirk of physics, a puzzle to be solved with careful consideration of reference frames and acceleration phases. But Einstein saw something far more sinister in this scenario. He recognized that the twin paradox wasn't just a theoretical curiosity, it was a preview of the psychological horror that awaited anyone who dared to approach light speed. Let's dig deeper into what the traveling twin would actually experience, beyond the sanitized version presented in physics classes. Imagine you're the twin embarking on this journey. You're traveling to a star, 20 light-years away at 99.5%, the speed of light. The math tells us that your round trip will take about 40 years from Earth's perspective, but only about 4 years from yours. But here's what Einstein realized the textbooks don't capture. You don't experience this time differential as a simple mathematical abstraction. You live through every moment of those 4 years, fully conscious and aware, while simultaneously knowing that decades are passing for everyone you've ever known. The psychological weight of this knowledge becomes crushing. During your first year of travel, you realize that your twin sibling on Earth has aged 10 years. Your parents, if they were elderly when you left, are likely dead. Your friends have moved on with their lives, formed new relationships, built careers, started families. The world you knew is disappearing while you watch stars slowly drift past your window. Einstein understood that this wasn't just about missing out on events. It was about the fundamental severing of human connection. We're social creatures whose identities are largely constructed through our relationships and shared experiences with others. The traveling twin doesn't just lose time, they lose the very foundation of human psychological well-being. But the horror deepens when you consider the return journey. As you approach Earth after what feels like 4 years away, you're returning to a world that has aged 40 years. Everyone you knew is either dead or has lived an entire additional lifetime in your absence. In your absence, the children you knew are now middle-aged adults, with children of their own. The young adults are now senior citizens. Your own twin sibling, once your closest companion and genetic equal, is now decades older than you, a living reminder of the time you've lost to the universe's cruel mathematics. Einstein realized that this temporal displacement creates a form of existential homelessness. You can never truly return home, because home exists in a time that no longer exists. You become a temporal refugee, displaced not in space, but in time itself. The Earth you return to may be physically the same planet, but it's populated by people who have lived through decades of history that you never experienced. The mathematical precision of relativity makes this horror even more acute. This isn't a vague sense of missing out or growing apart. It's an exact calculable displacement from the shared timeline of human experience. Every decimal place in your velocity translates to years or decades of lost connection with your species. Einstein began to see the twin paradox as a metaphor for the ultimate price of transcending human limitations. The twin who reaches for the stars doesn't gain the universe. They lose their place in the human story. They become living ghosts, displaced in time, carrying memories of a world that everyone else has left behind. This psychological dimension of time dilation revealed something that disturbed Einstein deeply. The universe's physical laws seemed designed to punish consciousness for trying to escape its natural limitations. The very qualities that make us human, our need for connection, our reliance on shared experience, our identity as temporal beings existing in a common now, are precisely what near-light speed travel destroys. The twin paradox wasn't just a physics problem to be solved. It was a warning about the price of cosmic ambition, a mathematical proof that some boundaries exist not to limit us, but to protect us from experiences that would fundamentally destroy what we are. Einstein's most disturbing realization about time dilation came not from the mathematics, but from a simple thought experiment he conducted in 1911. He imagined himself as a passenger on a near-light-speed spacecraft, looking out the window, and asked, what would I actually see happening to the universe around me? The answer terrified him. At 99% light speed, the universe outside your spacecraft becomes a cosmic time-lapse film running at 7 times normal speed. Stars that would normally burn for billions of years exhaust their fuel in what appears to be millions of years from your perspective. Red giant stars expand and collapse into white dwarfs in cosmic fast-forward. Entire stellar nurseries birth new stars and watch them evolve through their complete life cycles. But Einstein realized that the horror isn't just in the accelerated timescales. It's in your conscious awareness of what you're witnessing. You're not just observing accelerated cosmic evolution. You're watching the universe age and die while you remain essentially frozen in your own time stream. Galaxies spiral faster, their arms unwinding and reforming in patterns that would normally take hundreds of millions of years. Supernovae explode with increased frequency as massive stars race through their abbreviated lifetimes. Even the cosmic microwave background radiation shifts and evolves as the universe expands around you at an accelerated pace. Einstein understood that this accelerated cosmic perspective would create a profound psychological disconnect. You become a temporal voyeur, watching eons of cosmic history unfold like a movie, but unable to participate in or influence any of it. And you're simultaneously at the center of this cosmic drama and completely isolated from it. The psychological weight becomes even more crushing when you consider what's happening to Earth during your journey. Cities rise and fall, civilizations emerge, flourish and collapse, ice ages come and go, Continents drift across the planet's surface. Species evolve and go extinct. The entire saga of life on Earth accelerates before your eyes, while you remain locked in your own brief subjective time frame. Einstein realized that this temporal voyeurism would fundamentally alter human consciousness in ways we can barely comprehend. How do you maintain any sense of meaning or purpose when you're watching millions of years of history compressed into months of your experience? How do you cope with the knowledge that every civilization you observe rising will fall? Every species you see evolving will go extinct. Every mountain range forming will eventually erode to dust. This cosmic time-lapse effect revealed to Einstein one of the most cruel aspects of approaching light speed. You gain the perspective of geological and cosmic time, but you lose the ability to find meaning in human-scale events. You become a witness to the ultimate futility of all earthly endeavors, watching them play out in fast-forward, like scenes from a cosmic tragedy. Einstein began to understand that this temporal displacement wasn't just a side effect of high-speed travel. It was a fundamental violation of the psychological conditions necessary for conscious experience to remain meaningful. We're creatures adapted to find significance in human timescales, in the gradual unfolding of individual lives and civilizations. Time dilation forces us to confront cosmic timescales that render all human effort apparently meaningless. This was Einstein's first glimpse into what he would later call the temporal prison of light-speed travel. The universe's resistance to letting anything reach light speed wasn't just about energy requirements. It was about protecting conscious beings from a perspective that would make consciousness itself unbearable. In 1909, Einstein made a mathematical discovery that kept him awake for weeks. While working through the implications of his relativity equations, he realized that approaching light speed doesn't just distort time, it fundamentally alters the very fabric of space itself. This wasn't just about objects appearing smaller, it was about the actual contraction of spatial dimensions in ways that challenged everything humans believed about the permanence of physical reality. Length contraction, as physicists call it, reveals itself gradually as you accelerate toward light speed. At everyday velocities, the effect is negligible, so small that even our most precise instruments can't detect it. But as you approach significant fractions of light speed, space itself begins to compress in the direction of your motion, creating a distortion of reality that Einstein found deeply unsettling. Imagine you're traveling toward a distant star at 90% the speed of light. To you, inside your spacecraft, everything appears normal. Your coffee cup is still the same size, your cabin maintains its familiar dimensions, and you feel perfectly ordinary. But here's what Einstein realized would actually be happening. The distance to your destination has literally shrunk by more than half. A journey that should cover 10 light-years now covers only about 4.4 light-years from your perspective. This isn't just a measurement trick or an optical illusion. The space itself has contracted. The rulers you would use to measure distances have contracted by exactly the same amount, so you can't detect the effect from inside your reference frame. But from the perspective of someone watching your journey from Earth, your spacecraft has been compressed into a flattened disk, and the space you're traveling through has been shortened dramatically. Einstein found this deeply disturbing because it revealed that space, the stage upon which all of physics plays out, isn't the fixed, absolute arena that Newton had described. Space is malleable, elastic, and fundamentally dependent on motion. The very concept of distance becomes relative, changeable, and ultimately unreliable as an absolute measure of reality. But the mathematical horror intensifies as you approach ever closer to light speed. At 99% light speed, length contraction compresses distances by a factor of about 7. That 10 light-year journey now appears to cover only 1.4 light-years. At 99.9% light speed, the contraction factor jumps to 22. The journey appears to cover less than half a light-year. At 99.99%, the factor becomes 71, compressing the journey to about 0.14 light-years. Einstein realized that this exponential compression creates a form of spatial claustrophobia that would be psychologically unbearable. As you approach light speed, The entire universe ahead of you appears to contract into an increasingly narrow slice of space. Distant galaxies seem to rush toward you, not because you're moving toward them, but because the space between you and them is literally shrinking. This spatial compression revealed something that Einstein found philosophically terrifying. If space itself can contract, then our most basic assumptions about the nature of physical reality are wrong. We think of space as the permanent stage on which matter and energy perform their cosmic dance. But relativity shows us that space is just another actor in the play, as changeable and relative as time itself. The implications cascaded through Einstein's worldview, like dominoes falling. If space can contract, then the concept of fixed distances becomes meaningless. If distances can change depending on your motion, then the idea of objective spatial relationships between objects dissolves. If spatial relationships are relative, then our entire framework for understanding the physical universe becomes suspect. Einstein began to see length contraction, not just as a curious mathematical prediction, but as evidence that reality itself is far stranger and more fragile than human intuition suggests. We navigate the world assuming that the space around us is stable and permanent, but approaching light speed reveals that even our most basic spatial concepts are dependent on our state of motion. This realization marked a crucial turning point in Einstein's relationship with his own discoveries. The young physicist, who had been excited to explore the implications of high-speed travel, was beginning to understand that those implications threatened the very foundations of rational thought. How can you make sense of a universe where the fundamental dimensions of space and time are not absolute but relative? But length contraction was just the beginning of space's betrayal. As Einstein would discover, the spatial distortions of near-light speed travel don't just change measurements, they fundamentally alter the geometry of reality itself, creating a visual and conceptual nightmare that would challenge the very possibility of coherent perception. The mathematical implications of length contraction led Einstein to a realization so disturbing that he initially hoped his calculations were wrong. As you approach light speed, the universe doesn't just contract along your direction of motion, it begins to flatten into something resembling a two-dimensional plane, fundamentally altering the three-dimensional reality that makes spatial reasoning possible. To understand why this terrified Einstein, let's follow his thought experiment to its logical conclusion. Imagine you're now traveling at 99.99%, the speed of light, where length contraction has become so extreme that distances ahead of you have compressed by a factor of 71. But here's what Einstein realized. This compression only affects the dimension parallel to your motion. The dimensions perpendicular to your travel remain unchanged. Picture what this means for your perception of reality. A spherical planet that you're approaching would appear compressed into a flattened disk when viewed from the front, but maintain its full diameter when viewed from the side. A cubic space station would be squeezed into a thin rectangular sheet in the direction of your motion, while preserving its full width and height. The entire three-dimensional universe ahead of you becomes increasingly pancaked into a flattened approximation of its true form. Einstein worked through the visual implications with growing horror as you approach 99.999% light speed, with length contraction now squeezing space by a factor of 224. Entire star systems would appear flattened into paper-thin disks. Globular clusters containing hundreds of thousands of stars would be compressed into what look like flat, circular patterns of light. Even vast spiral galaxies would appear as thin edge-on slices, their majestic three-dimensional structure reduced to compressed shadows of their true form. But the psychological implications disturbed Einstein even more than the visual distortions. Human spatial reasoning depends on our ability to perceive and navigate three-dimensional space. We understand our environment by recognizing the relationships between objects that exist in front, behind, above, below, left, and right of us. Length contraction systematically destroys this spatial framework by compressing one of the three fundamental dimensions of reality. Einstein realized that this flattening effect would create a form of perceptual hell for any conscious observer. How do you navigate through space when depth perception becomes meaningless? How do you judge distances when the entire concept of distance ahead has been compressed to nearly zero? How do you maintain any sense of spatial orientation when the universe has been squeezed into a flattened approximation of reality? The mathematics revealed an even more disturbing implication. As you continue to accelerate closer to light speed, the flattening becomes more extreme with each increment of velocity. At 99.9999% light speed, length contraction reaches a factor of 707. The universe ahead of you becomes so compressed that entire galaxies appear as thin lines of light. At 99.99999%, the contraction factor explodes to over 2000, flattening reality into something barely distinguishable from a two-dimensional projection. Einstein began to understand that this exponential flattening wasn't just changing your perception of the universe, it was systematically destroying the dimensional framework that makes spatial cognition possible. Three-dimensional thinking requires the ability to perceive depth, volume, and the relationships between objects separated by meaningful distances. Length contraction reduces all of these concepts to meaningless approximations. But perhaps most disturbing of all was Einstein's realization that this flattening process reveals the arbitrary nature of our three-dimensional experience. We take three-dimensional space for granted as the fundamental structure of reality, but approaching light speed shows us that even dimensionality itself is relative to motion. The universe doesn't have an absolute number of meaningful dimensions. It has whatever number of dimensions your velocity allows you to perceive. This insight shook Einstein's confidence in the objectivity of physical reality. If the number of spatial dimensions you can meaningfully perceive depends on your velocity, then what does it mean to say that space really has three dimensions? Is three-dimensional space just an artifact of our slow-moving existence, no more fundamental than the flattened space perceived by a near-light-speed traveler? Einstein spent months grappling with these questions, and the answers he found were profoundly unsettling. The mathematics seemed to suggest that reality itself doesn't have fixed dimensional properties, that even something as basic as the number of meaningful spatial dimensions is relative to the observer's state of motion. This wasn't just physics anymore. It was a philosophical crisis that threatened the very foundations of rational thought about the nature of existence. The flattening of reality revealed to Einstein that approaching light speed doesn't just change your relationship with space, it destroys the conceptual framework that makes spatial reasoning possible. You don't just travel through a compressed universe, you become trapped in a dimensional prison where the very concepts needed to understand your situation have been systematically eliminated by the mathematics of your motion. This was Einstein's first glimpse into what he would later call the geometric nightmare of light-speed travel. The universe's resistance to letting anything reach light speed wasn't just about energy requirements or time dilation. It was about protecting conscious beings from a perceptual experience that would make spatial cognition impossible. But the flattening of space was just one dimension of the geometric horror that awaited near-light speed travelers. As Einstein would discover, the compression of reality creates visual and perceptual distortions so severe that they threaten not just spatial understanding, but the very possibility of coherent sensory experience. By 1912, Einstein had worked through the mathematical implications of length contraction so thoroughly that he began experiencing what he privately called spatial nightmares, vivid dreams in which he found himself trapped in geometrically impossible spaces where normal concepts of distance and dimension had broken down completely. These weren't just abstract mathematical concerns anymore. Einstein had begun to understand that the spatial distortions of near-light speed travel would create a form of sensory experience so alien that it might drive conscious observers insane. The flattening of reality wasn't just a curious side effect. It was a systematic assault on the cognitive frameworks that make rational thought possible. Einstein's nightmares typically involved finding himself in corridors that stretched infinitely in some directions, while being compressed to paper-thin slices in others. He would reach for objects that appeared to be within arm's length, only to discover they were actually light years away in their compressed dimension. Familiar shapes would become unrecognizable as their proportions were distorted beyond any possibility of visual understanding. But the real horror in Einstein's spatial nightmares came from the realization that these weren't just dreams. They were accurate previews of what consciousness would experience during near-light speed travel. The mathematical predictions of length contraction weren't describing abstract geometric relationships. They were describing the actual perceptual environment that any traveler would have to navigate. Einstein understood that human consciousness evolved in a three-dimensional world with stable spatial relationships. Our brains are wired to recognize patterns, judge distances, and navigate through space based on consistent geometric principles. Length contraction systematically violates every one of these principles, creating a perceptual environment that our cognitive systems are fundamentally incapable of processing coherently. The psychological implications kept Einstein awake at night.
How would a conscious mind cope with existing in a reality where forward and backward had been compressed into meaninglessness while left, right, up, and down retained their full dimensions? How would you maintain any sense of spatial orientation when the very geometry of your environment defied every evolved instinct about how space should behave?
Einstein began to see the spatial distortions of relativity as evidence that the universe contains built-in protections against experiences that would destroy consciousness itself. The exponential energy requirements that prevent anything from reaching light speed weren't just physical limitations. They were cosmic safeguards protecting aware beings from perceptual experiences that would make awareness itself impossible. His spatial nightmares revealed something profound about the relationship between consciousness and physical reality. We don't just observe the universe from within space. We are spatial beings whose very capacity for rational thought depends on the stability and consistency of geometric relationships. When space itself becomes unreliable, consciousness loses its foundation. Einstein realized that this wasn't just a problem for hypothetical future space travelers. It was a fundamental insight into the nature of conscious experience itself. We exist as thinking beings only because we inhabit a universe with stable spatial dimensions that our minds can comprehend. Einstein realized that this wasn't just a problem for hypothetical future space travelers. Approaching light speed reveals how fragile this relationship really is. The spatial nightmare of near-light speed travel became, for Einstein, a metaphor for the ultimate price of transcending natural limitations. The desire to move faster, to explore further, to push beyond the boundaries of normal human experience, inevitably leads to the destruction of the very cognitive frameworks that make experience meaningful. This realization marked a turning point in Einstein's thinking about his own discoveries. The physicist, who had revolutionized our understanding of space and time, was beginning to understand that some knowledge comes with a terrible price. The knowledge that the universe we think we understand is far stranger and more fragile than we ever imagined. In 1913, Einstein made a mathematical discovery that would haunt him for the rest of his life. While refining his equations for relativistic mass increase, he realized that the universe doesn't just make light speed travel difficult, it makes it impossibly violent. As any object with mass approaches the speed of light, its relativistic mass approaches infinity, creating what Einstein came to see as nature's most aggressive defense against conscious beings reaching the cosmic speed limit. The concept of relativistic mass increase initially seemed like just another curious mathematical prediction. At low speeds, the effect is negligible. A car traveling down a highway gains such a tiny amount of relativistic mass that even our most sensitive instruments couldn't detect the difference. But Einstein's equations revealed that this effect doesn't remain gentle. It explodes exponentially as you approach light speed. At 50% the speed of light, an object's relativistic mass increases by only about 15%, significant for precise calculations, but hardly dramatic. At 90% light speed, the mass increase jumps to about 130%, more than double the object's rest mass. At 99% light speed, the relativistic mass becomes about 7 times greater than the original. The numbers are large, but still comprehensible. But here's where Einstein's mathematics becomes genuinely terrifying. The relativistic mass doesn't just increase. It races toward infinity with exponential violence. At 99.9% light speed, mass increases by a factor of 22. At 99.99%, it jumps to 71 times the rest mass. At 99.999%, the factor explodes to 224. Each additional decimal place of velocity, accuracy, sends the mass multiplier rocketing toward mathematical infinity. Einstein realized that this exponential mass increase represents the universe's most brutal prohibition against light-speed travel. Imagine trying to accelerate a spacecraft that's already traveling at 99.99% light speed. Its mass has increased by a factor of 71, meaning it now requires 71 times more force to achieve the same acceleration. But as you push it even slightly faster, its mass explodes exponentially, requiring ever more enormous forces for ever smaller gains in velocity. The mathematical horror intensifies when you consider what this means for any conscious being aboard such a spacecraft. As your vessel's relativistic mass approaches infinity, you're not just becoming harder to accelerate, you're becoming a cosmic object whose gravitational field approaches that of a black hole. The space around you begins to warp severely as your mass energy warps the fabric of space-time itself. Einstein worked through the implications with growing dread. A near-light-speed spacecraft wouldn't just be difficult to steer, it would become gravitationally dangerous to anything in its vicinity. Its passage through space would create gravitational waves, bend light paths, and potentially disrupt the orbits of planets and moons. The very act of approaching light speed would transform you from an explorer into a cosmic hazard. But the real nightmare lies in understanding what infinite mass would actually mean. Infinity isn't just a very large number. It's a mathematical concept that breaks the logical structure of physics itself. An object with infinite mass would have infinite gravitational attraction, infinite momentum, and would require infinite energy to deflect from its path. Such an object wouldn't just be difficult to control, it would be impossible to control, even in principle. Einstein began to see the exponential mass increase as evidence that the universe contains mathematical safeguards against experiences that would destroy not just consciousness, but the very possibility of rational physics. The approach toward infinite mass isn't just a practical limitation, it's nature's way of saying that some boundaries cannot and must not be crossed. The violence of this mathematical prohibition disturbed Einstein, because it revealed something disturbing about the fundamental structure of reality. The universe doesn't just make light-speed travel difficult, it makes it increasingly violent and destructive as you get closer. It's as if nature is designed to punish any attempt to transcend its speed limit with ever-increasing brutality. This realization transformed Einstein's understanding of physical limits. He began to see the relativistic mass increase not as an arbitrary mathematical quirk, but as evidence that the universe contains built-in ethical constraints. Some boundaries exist not to limit exploration, but to prevent exploration from becoming destruction. The exponential approach toward infinite mass revealed to Einstein that the cosmic speed limit isn't just about energy or engineering. It's about protecting the universe from objects that would become ungovernable cosmic hazards. The mathematics were showing him that consciousness and near-light speed travel aren't just practically incompatible, they're morally incompatible. The mathematical relationship between velocity and energy requirements revealed to Einstein perhaps the most elegant and brutal truth about the universe's design. Nature doesn't just prohibit light-speed travel, it makes the prohibition absolute through the mathematics of infinite energy demand. Einstein's energy equations showed that accelerating any massive object requires energy proportional to the velocity change. At normal speeds, this relationship is linear and manageable. Doubling your car's speed requires roughly 4 times the energy. Tripling the speed needs 9 times the energy. This follows predictable, comprehensible patterns that engineers can work with. But approaching light speed shatters this comfortable predictability. The energy requirements don't just increase, they explode toward infinity with the same exponential violence as relativistic mass. At 90% light speed, you need about 2.3 times the energy that classical physics would predict. At 99%, the factor jumps to about 7. At 99.9%, it becomes 22. At 99.99%, you need 71 times more energy than Newton's equations would suggest. Einstein realized that these numbers represent more than just engineering challenges. They represent mathematical proof that the universe prohibits light-speed travel absolutely. The energy curve doesn't level off at some high but achievable value. It races toward infinity, meaning that the final approach to light speed would require literally infinite energy. Think about what infinite energy actually means. It's not just more energy than we can generate with current technology, or more than our solar system produces, or more than our galaxy contains. Infinite energy means more energy than exists in the entire observable universe. Even if you could somehow convert every star, every planet, every atom in the cosmos into pure energy and focus it all on accelerating a single proton, you still wouldn't have enough energy to reach exactly the speed of light. This mathematical impossibility revealed something profound to Einstein about the structure of reality. The universe isn't just difficult to transcend, it's designed to be impossible to transcend. The energy requirements create an absolute barrier that cannot be overcome through any conceivable advance in technology or understanding. But Einstein found the exponential nature of this energy curve particularly disturbing. The universe doesn't just say no to light-speed travel. It says no with increasing violence as you approach the limit. Each increment of speed near light velocity requires exponentially more energy than the last, creating a mathematical crescendo of impossibility that becomes more brutal with each step. This exponential energy curve also revealed the cruel, teasing nature of the light speed limit. You can always get closer. 99.9% is achievable in principle, as is 99.99% and 99.999%. The mathematics never absolutely forbid the next decimal place of accuracy, but each additional decimal place requires exponentially more energy, creating an infinite series that can never be completed. Einstein began to see this energy barrier as evidence that the universe contains built-in wisdom about the relationship between conscious ambition and cosmic limits. The exponential energy requirements don't just prevent light-speed travel, they teach us that some goals become self-defeating when pursued to their logical extremes. The infinite energy demand revealed to Einstein that approaching light speed represents a fundamental category error in thinking about cosmic exploration. We imagine that going faster is always better, that pushing limits is inherently valuable, that transcending boundaries represents progress. But the mathematics show us that some boundaries exist to protect us from goals that would consume everything in their pursuit. This was Einstein's first glimpse into what he would later call the mathematical wisdom of physical limits. The universe's energy requirements weren't arbitrary restrictions. They were protective barriers that prevent conscious beings from pursuing objectives that would ultimately destroy the very foundations of existence itself. By 1915, Einstein had worked through enough of the mathematical implications of approaching light speed to reach a conclusion that fundamentally changed his worldview. The cosmic speed limit isn't just a physical barrier. It's evidence that the universe contains built-in ethical constraints designed to protect conscious existence from self-destruction. This realization came to Einstein not through philosophical speculation, but through rigorous mathematical analysis of what would actually happen if the light-speed barrier could somehow be overcome. The equations revealed that faster-than-light travel wouldn't just be difficult or dangerous, it would destroy the logical structure of causality itself, making rational existence impossible. Einstein's breakthrough came when he realized that the speed of light isn't just the speed at which electromagnetic radiation travels, it's the speed at which causality itself propagates through space-time. Information about events can't travel faster than light because causality can't travel faster than light. This isn't a technological limitation that advanced civilizations might overcome. It's a fundamental feature of the logical structure of reality. To understand why this disturbed Einstein so deeply, imagine what faster-than-light communication would actually mean. If you could send a message faster than light, you could potentially send information into the past. Not dramatically into the past, just slightly, by fractions of seconds or minutes. But Einstein realized that even tiny violations of causality would create logical paradoxes that would make rational thought impossible. The mathematics revealed something even more disturbing. Faster-than-light travel would allow you to attend your own funeral. Through careful manipulation of reference frames and faster-than-light journeys, you could potentially arrive at a destination before you left your starting point. This isn't science fiction speculation. It's a direct mathematical consequence of exceeding the speed of light in Einstein's relativistic universe. Einstein understood that these temporal paradoxes weren't just curious theoretical possibilities. They represented a fundamental threat to the logical coherence of existence. In causality is the principle that effects follow causes in a predictable sequence. It's the foundation of rational thought, scientific investigation, and meaningful action. Faster-than-light travel would shatter this foundation, creating a universe where effects could precede their causes and logical reasoning would become impossible. This realization revealed to Einstein why the universe's prohibition against faster-than-light travel is so absolute and violent. It's not just about energy requirements or engineering challenges. It's about protecting the logical structure of reality itself. The exponential energy curve that prevents anything from reaching light speed isn't a cruel limitation. It's a cosmic safeguard protecting conscious beings from destroying the very foundations of rational existence. Einstein began to see the light speed limit as evidence of what he privately called universal wisdom, the idea that the physical laws of reality contain built-in protections against experiences that would make conscious existence impossible or meaningless. The universe doesn't just permit consciousness to exist, it actively protects consciousness from its own potentially self-destructive ambitions. But this protective function of physical limits disturbed Einstein on a philosophical level. It suggested that free will itself might be constrained by mathematical necessity. If the universe contains built-in protections against certain types of conscious choice, then consciousness isn't as free as we imagine. We can choose to pursue light-speed travel, but the mathematics ensure that we can never actually achieve it. This insight into the relationship between physical limits and conscious choice marked a crucial turning point in Einstein's thinking. The young physicist, who had been excited to explore the implications of transcending human limitations, was becoming a mature thinker who understood that some limitations exist to preserve the very possibility of meaningful choice. Einstein realized that the light speed limit represents a profound cosmic compromise. Consciousness is permitted to exist and explore, but within boundaries that prevent exploration from becoming self-destruction. We can push against these limits, learn from them, and even approach them asymptotically, but we cannot cross them without destroying the logical framework that makes consciousness possible. This understanding transformed Einstein's relationship with his own discoveries. He began to see relativity not just as a description of how fast objects can travel, but as a revelation of how the universe protects conscious beings from experiences that would make consciousness itself impossible. The ultimate speed limit revealed to Einstein that the universe is not indifferent to consciousness. It's designed in ways that make consciousness possible and protect it from its own potentially destructive ambitions. The light speed barrier isn't a limitation on cosmic exploration. It's the foundation that makes cosmic exploration meaningful by preserving the logical coherence necessary for explorers to exist. In the winter of 1916, Einstein made a discovery that terrified him more than any other implication of his relativity theory. While working through the mathematics of faster-than-light communication, he realized that exceeding the cosmic speed limit wouldn't just be physically impossible, it would create logical paradoxes so severe that they would destroy the rational structure of existence itself. This was Einstein's first encounter with what physicists now call causality violation, but what Einstein privately termed the death of reason. The mathematical pathway to this horror began with a deceptively simple question: what would happen if information could travel faster than light? Einstein initially approached this as a purely theoretical exercise, but the equations led him into a logical nightmare that challenged everything he believed about the nature of rational reality. To understand Einstein's terror, let's follow his mathematics step by step. Imagine you've developed a faster-than-light communication device, perhaps some kind of quantum entanglement transmitter that can send messages instantaneously across vast distances. At first glance, this seems like pure benefit, instant communication with distant stars, immediate coordination of space missions, the end of cosmic isolation. But Einstein's equations revealed a hidden horror in this scenario. In relativity, simultaneity is relative. Events that appear simultaneous to one observer may not be simultaneous to another observer moving at high velocity. This seems like an abstract mathematical quirk until you combine it with faster-than-light communication. Then it becomes a recipe for logical catastrophe. Here's the specific nightmare that kept Einstein awake. If Alice is moving at high velocity relative to Bob, and they both have faster-than-light communicators, they can use these devices to send messages into each other's past. Not dramatically into the past, just slightly, by minutes or hours. But Einstein realized that even tiny violations of causality would create logical contradictions that would make rational existence impossible. The mathematical proof is elegant and terrifying. Alice sends a faster-than-light message to Bob at time t. Due to the relativity of simultaneity, Bob receives this message at what appears to him to be time t minus some small interval. Effectively, he receives the message before Alice sent it from his perspective. Bob can then use his own faster-than-light transmitter to send a reply back to Alice, arriving at a time before she sent her original message. Einstein worked through this scenario with growing dread, realizing that it creates what logicians call a causal loop, a sequence of events that precede their own causes. Alice receives Bob's reply before she sends her original message. She now has information that came from her own future, creating a logical contradiction that threatens the coherence of rational thought itself. But the mathematical horror deepens when you consider the implications for free will and rational choice. If Alice receives information from her own future, she can choose to act on that information, potentially preventing herself from sending the original message that created the information in the first place. But the mathematical horror deepens when you consider the implications for free will and rational choice. This creates what philosophers call a grandfather paradox, a situation where an effect prevents its own cause. Einstein realized that these causality violations wouldn't just create interesting logical puzzles, they would make rational existence impossible. Rational thought depends on the principle that causes precede effects in a predictable sequence. If effects can precede causes, then the logical foundation of reasoning collapses. You could receive the solution to a problem before identifying the problem, learn the consequences of decisions before making them, or discover the results of experiments before conducting them. The mathematical inevitability of these paradoxes revealed to Einstein something profound and disturbing about the structure of reality. The universe must be designed to prevent faster-than-light information transfer, not just as a practical limitation, but as a logical necessity. The speed of light isn't just the maximum velocity for matter and energy, it's the maximum speed at which causality itself can propagate. This insight transformed Einstein's understanding of the cosmic speed limit. He began to see it not as an arbitrary physical constraint, but as a fundamental logical requirement for rational existence to be possible. The universe permits consciousness to exist, but only within a framework that preserves the causal structure necessary for conscious reasoning to function. Einstein's mathematical exploration of causality violation revealed something even more disturbing. The universe appears to be fine-tuned to support rational thought. The speed of light is exactly the speed needed to prevent information from traveling into the past and creating logical paradoxes. If light traveled faster, causality would break down. If it traveled slower, the universe would be more constrained than necessary. The actual speed of light seems precisely calibrated to permit maximum freedom of action, while preserving the logical coherence necessary for action to be meaningful. This fine-tuning disturbed Einstein because it suggested that consciousness and physical reality are more intimately connected than he had imagined. The universe doesn't just happen to contain conscious beings, it appears to be structured in ways that make consciousness possible and protect it from logical self-destruction. The causality breakdown that would result from faster-than-light travel revealed to Einstein the ultimate wisdom in the cosmic speed limit. The universe's violent resistance to anything exceeding light speed isn't cruel or limiting, it's protective. The exponential energy requirements, the infinite mass increase, the temporal paradoxes, all of these apparent barriers are actually safeguards, protecting rational existence from destroying itself through its own ambitions. Einstein began to see the prohibition against faster-than-light travel as evidence of what he called cosmic ethics. The idea that the physical laws of reality contain built-in moral constraints that prevent conscious beings from pursuing goals that would destroy the very possibility of conscious existence. But this protective function of causality raised disturbing questions about the nature of free will itself. If the universe contains mathematical safeguards against certain types of conscious choice, then consciousness isn't as free as we imagine. We can choose to pursue faster-than-light travel, but the mathematics ensure that such pursuit will always fail, not just practically, but logically. Einstein's exploration of causality violation led him to a realization that combined the terror of time travel paradoxes with the precision of mathematical physics. The grandfather paradox, the idea that you could travel back in time and prevent your own birth, wasn't just science fiction, speculation. It was a direct mathematical consequence of faster-than-light travel in Einstein's relativistic universe. The traditional grandfather paradox is usually presented as a thought experiment about time travel. If you could travel back in time and kill your grandfather before he had children, you would prevent your own birth, making it impossible for you to travel back in time in the first place. The paradox creates a logical contradiction that seems to make time travel impossible. But Einstein realized that faster-than-light travel creates essentially the same paradox through the relativity of simultaneity, without requiring dramatic time travel scenarios. The mathematics of special relativity showed him that exceeding the speed of light would inevitably create situations where effects could precede their causes, generating the same types of logical contradictions that make the grandfather paradox so troubling. Here's how Einstein worked through the physics version of this paradox. Imagine you're conducting a faster-than-light experiment. You send a signal from Earth to a space station orbiting a distant star, and the station is programmed to send an automatic reply when it receives your signal. Due to the relativity of simultaneity and faster-than-light propagation, this reply could arrive back at Earth before you sent the original signal. Now you're faced with a grandfather paradox in purely physical terms. You receive a reply to a message you haven't sent yet. You could choose to act on this information by not sending the original message, thereby preventing the reply that you've already received. This creates the same logical contradiction as the traditional grandfather paradox, an effect, the reply preventing its own cause, the original message. Einstein found this physical version of the grandfather paradox even more disturbing than the time travel version, because it didn't require exotic technologies or speculative theories about time machines. It was a direct mathematical consequence of his own well-established equations. If faster-than-light communication were possible, causality violations wouldn't just be theoretical possibilities. They would be inevitable, measurable, repeatable, experimental results. The mathematical precision of this paradox revealed to Einstein something profound about the relationship between physical law and logical coherence. The universe isn't just governed by mathematical equations, it's governed by mathematical equations that preserve the logical structure necessary for rational thought to be possible. The prohibition against faster-than-light travel isn't just a physical constraint, it's a logical requirement for coherent existence. Einstein began to see the grandfather paradox of physics as evidence that the universe contains what he called built-in wisdom about the relationship between consciousness and causality. The speed of light limit doesn't just prevent practical problems, it prevents logical problems that would make consciousness itself impossible. But this insight disturbed Einstein, because it suggested that free will operates within much more restrictive boundaries than we imagine. If the universe automatically prevents us from making choices that would create logical contradictions, then our freedom to choose is constrained by mathematical necessity. We can intend to violate causality, but the structure of reality ensures that such intentions can never be successfully carried out. The grandfather paradox of physics also revealed the protective function of apparently arbitrary physical limits. Einstein realized that many of the constraints that seem to limit human ambition, the speed of light, the uncertainty principle, the impossibility of perpetual motion, might actually be safeguards protecting conscious beings from destroying the logical foundations of their own existence. This understanding transformed Einstein's relationship with physical impossibility. Instead of seeing impossible things as challenges to be overcome through better technology or deeper understanding, he began to see some impossibilities as beneficial constraints that make meaningful existence possible. The grandfather paradox of physics taught him that not all limitations are meant to be transcended. Einstein's exploration of causality violation through faster-than-light travel revealed that the universe operates according to what he called ethical mathematics. Equations that don't just describe how things behave, but ensure that conscious beings can't accidentally destroy the logical coherence necessary for consciousness itself. The grandfather paradox of physics became, for Einstein, a mathematical proof that consciousness and cosmic transcendence are fundamentally incompatible. The very ambitions that drive conscious beings to push beyond natural limits, the desire to communicate instantly across vast distances, to travel faster than anything in nature, to transcend the apparent constraints of physical reality, would destroy the causal structure that makes consciousness possible in the first place. Einstein's most disturbing realization about causality violation came when he understood that the cosmic speed limit applies not just to matter and energy, but to information itself. This wasn't just about spacecraft or communication devices. It was about the fundamental speed at which knowledge, influence, and even the possibility of rational cause and effect relationships can propagate through reality. The mathematics revealed something profound. Information is not separate from the physical universe. It's woven into the very fabric of space-time itself. When Einstein worked through the equations governing information transfer, he discovered that knowledge itself cannot travel faster than light without creating the same causality violations that make rational existence impossible. This insight terrified Einstein because it revealed that the speed of light isn't just a limit on physical travel, it's a limit on the speed of knowledge itself. In a universe where information could travel instantaneously, you could know the outcomes of events before their causes occurred. You could receive answers before asking questions, learn consequences before making decisions, and understand results before conducting experiments. Einstein realized that such instantaneous information transfer would destroy the logical sequence that makes learning and rational thought possible. Knowledge depends on causality. We understand relationships between events because causes reliably precede effects. If information could travel faster than light, this causal structure would collapse, making coherent knowledge impossible. The mathematical proof was elegant and horrifying. If you could send information faster than light, you could, through careful manipulation of reference frames, send that information into the past. This would create what Einstein called information loop situations, where knowledge arrives before the events that created it, making it impossible to determine what actually caused what. But Einstein discovered something even more disturbing. These information loops wouldn't just create logical puzzles. They would make the concept of objective truth meaningless. If effects can precede causes in the realm of information, then there's no stable foundation for determining what actually happened, when it happened, or why it happened. Einstein began to see the information speed limit as the universe's way of protecting not just rational thought, but the very possibility of objective knowledge. The speed of light doesn't just limit how fast we can travel or communicate, it limits how fast truth itself can propagate, ensuring that knowledge maintains its logical coherence. This realization revealed why Einstein found faster-than-light travel so disturbing. It wouldn't just be dangerous or impractical, It would make the scientific method itself impossible. Science depends on the principle that we can study causes and observe their effects in a reliable temporal sequence. Faster-than-light information transfer would shatter this sequence, making scientific knowledge impossible. Einstein understood that the information speed limit preserves something more fundamental than just rational thought. It preserves the possibility of rational thought having any meaningful relationship to reality without causality. Knowledge becomes arbitrary. Without temporal sequence, learning becomes impossible. Without the speed of light limit on information, consciousness loses its foundation in objective reality. The information speed limit revealed to Einstein the ultimate wisdom in the cosmic speed limit. The universe doesn't just protect conscious beings from physical dangers, it protects consciousness itself from losing its grounding in rational reality. The prohibition against faster-than-light information transfer isn't a limitation on knowledge, it's the foundation that makes knowledge possible. This insight transformed Einstein's understanding of the relationship between consciousness and physical law. He began to see the speed of light not as an arbitrary constant, but as the fundamental parameter that makes rational existence possible. It's the speed at which causality propagates, the maximum rate at which knowledge can maintain its logical coherence, and the protective barrier that prevents consciousness from destroying its own foundations. Einstein realized that information's speed limit represents the universe's deepest commitment to supporting rational existence. By ensuring that knowledge cannot travel faster than causality itself, the universe preserves the logical structure that makes consciousness meaningful, scientific investigation possible, and rational choice coherent. Einstein realized if information's speed limit represents the universe's deepest commitment to supporting rational existence. In 1917, Einstein made perhaps his most psychologically disturbing discovery about the nature of light-speed travel. While working through the mathematics of what physicists call the photon's reference frame, he realized that from the perspective of light itself, time doesn't just slow down, it stops completely. A photon experiences no temporal passage whatsoever during its journey, regardless of whether that journey covers inches or billions of light years. This wasn't just another mathematical curiosity. Einstein understood that this timeless perspective of light revealed something terrifying about what consciousness would experience if it could somehow approach the speed of light. The closer you get to light speed, the closer you approach a state of existence where time becomes meaningless, where past, present, and future collapse into a single eternal moment. To understand why this disturbed Einstein so profoundly, consider what living in the eternal now would actually mean for a conscious observer. At 99% the speed of light, your subjective experience of time slows by a factor of about 7. A journey that takes years in the outside universe feels like months to you. Strange, but still comprehensible as a temporal experience with a beginning, middle, and end. But as you approach closer to light speed, the time dilation factor explodes exponentially. At 99.9% light speed, time slows by a factor of 22. At 99.99%, the factor becomes 71. At 99.99%, it jumps to 224. Tide of 24. The numbers race toward infinity, meaning that your subjective experience of time races towards zero. Einstein realized that this exponential approach toward timelessness would create a form of psychological horror that's almost impossible to describe. As your journey time approaches zero, you begin to experience something that consciousness was never designed to handle: existence without temporal flow. The past doesn't fade into memory, and the future doesn't approach gradually. Everything happens simultaneously in an eternal, unchanging present moment. But the mathematical horror deepens when you consider what this means for conscious experience itself. Human consciousness is fundamentally temporal. We exist as a stream of experiences that flow from past through present toward future. Memory, anticipation, learning, growth, even the basic experience of being aware, all of these depend on the passage of time. Consciousness without temporal flow isn't just different from normal experience. It's arguably not consciousness at all. Einstein worked through the psychological implications with growing dread. In the photon's eternal now, there's no sequence of thoughts, no progression of experiences, no sense of journey or development. Everything that defines conscious existence, the ability to learn, to change, to grow, to experience cause and effect, becomes meaningless in a timeless state. This insight revealed to Einstein why the universe's resistance to light-speed travel becomes so violent as you approach the limit. Whole ideria sediari. Further beat dairy, it's not just that the energy requirements become infinite or that mass approaches infinity. It's that consciousness itself approaches a state that makes conscious experience impossible. The mathematical barriers protecting the speed of light aren't just protecting physics, they're protecting the very possibility of awareness. Einstein began to understand that the timeless perspective of light represents a kind of existential death that's worse than physical death. Physical death ends consciousness, but approaching light speed traps consciousness in a state where the temporal flow that makes awareness possible ceases to exist. You don't die, you become trapped in an eternal moment where the very concepts that define conscious existence lose all meaning. The photon's perspective revealed to Einstein something profound about the relationship between consciousness and time. We don't just exist in time, we are temporal beings whose very capacity for awareness depends on the flow of time. Without temporal passage, consciousness doesn't just become different, it becomes impossible. This realization marked a crucial turning point in Einstein's thinking about the desirability of transcending human limitations. The young physicist, who had dreamed of riding alongside light beams, was beginning to understand that such a journey wouldn't lead to transcendence. It would lead to the destruction of everything that makes transcendence meaningful. Einstein's exploration of the photon's timeless existence revealed that approaching light speed doesn't just change your relationship with time, it destroys the temporal foundation that makes conscious relationships possible. The eternal now isn't a state of enlightenment or transcendence, it's a mathematical prison where consciousness loses the temporal flow that makes consciousness possible. This understanding of time's relationship to awareness would haunt Einstein for the rest of his life, informing his growing conviction that some boundaries exist, not to limit consciousness, but to preserve the very conditions that make consciousness possible in the first place. Einstein's exploration of the photon's perspective led him to a realization so disturbing that he initially refused to accept its implications. From light's point of view, the entire history of the universe, from the Big Bang to the heat death of the cosmos, occurs simultaneously in a single timeless instant. This wasn't just a mathematical abstraction. It was a preview of what consciousness would experience at light speed, the complete collapse of temporal sequence into an overwhelming, incomprehensible simultaneity. The mathematical pathway to this horror began with Einstein's calculation of proper time for a photon. Proper time is the time experienced by an object as measured by a clock traveling with that object. For objects moving at normal speeds, proper time passes at nearly the same rate as time measured by stationary observers. But for a photon traveling at exactly the speed of light, proper time doesn't just slow down, it stops completely. This means that from a photon's perspective, its entire journey, whether it travels from your flashlight to the wall, or from a distant galaxy to your eye across billions of years, takes exactly 0 time. The photon experiences its emission and absorption as simultaneous events. There is no journey, no travel time, no experience of moving through space. There is only an instantaneous transition from emission to detection. Einstein realized that this timeless photon perspective reveals something terrifying about what approaching light speed would do to conscious experience. As you get closer to light speed, your subjective experience of time approaches the photon's timeless state. So, at the limit, you would experience the entire universe's history as a single simultaneous moment. Imagine the psychological horror of this state. Every event that has ever occurred, or will ever occur in the universe, the formation of the first stars, the evolution of life on Earth, the eventual death of the sun, the final heat death of the cosmos, all happening at once in your awareness. With signal, not sequentially, not as a movie played at incredible speed, but simultaneously, as overlapping, concurrent experiences that your consciousness somehow has to process all at once. Einstein worked through the implications with growing terror. Human consciousness evolved to process experiences sequentially, one moment at a time. We understand the universe by experiencing it as a temporal flow, where causes precede effects, where events unfold in logical sequence, where we can focus our attention on one moment, while memories of the past inform our expectations of the future. But the photon's perspective destroys this entire framework. In the timeless state of light speed, there's no past to remember, no future to anticipate, no present moment to focus on. Everything exists simultaneously in an eternal, unchanging, now that contains all of cosmic history, compressed into a single instant of awareness. The mathematical precision of this simultaneity made it even more disturbing to Einstein. This wasn't a vague mystical concept about transcending time. It was an exact mathematical prediction of what relativity theory says would happen to consciousness at light speed. The equations don't just describe the physical properties of light. They describe the experiential state that any conscious observer would enter if they could somehow reach light speed. Einstein began to understand that this cosmic simultaneity represents the ultimate breakdown of rational consciousness. Rational thought depends on the ability to sequence information, to process cause and effect relationships, to distinguish between past knowledge and present experience. In the photon's eternal instant, all of these cognitive foundations collapse into an incomprehensible simultaneity. But perhaps, most disturbing of all, was Einstein's realization that this simultaneous experience of all cosmic history wouldn't be transcendent or enlightening. It would be psychologically devastating. Consciousness isn't designed to process infinite information simultaneously. The human mind that tried to experience the entire universe's history as a single moment wouldn't achieve cosmic enlightenment. It would suffer complete cognitive breakdown. Einstein imagined the psychological state of a consciousness trapped in the photon's perspective, witnessing the birth and death of every star simultaneously, experiencing the rise and fall of every civilization at once, feeling the joy and suffering of every conscious being throughout cosmic history as concurrent experiences. The mind wouldn't transcend its limitations. It would be crushed by the infinite weight of simultaneous cosmic experience. This insight revealed to Einstein why the universe's prohibition against reaching light speed is so absolute and violent. It's not just protecting conscious beings from physical dangers. It's protecting consciousness from an experiential state that would destroy the very foundations of rational awareness. The speed of light barrier doesn't limit consciousness. It preserves the temporal framework that makes consciousness possible. Einstein began to see the photon's timeless perspective as evidence of what he called the universe's mercy. The mathematical barriers that prevent anything with mass from reaching light speed aren't cruel limitations. They're protective constraints that prevent consciousness from entering a state where conscious experience becomes impossibly overwhelming. The simultaneous universe of the photon's perspective revealed to Einstein that some forms of transcendence are indistinguishable from destruction. The desire to experience reality from light's perspective, to see the universe as light sees it, isn't a noble aspiration toward greater understanding. It's an unconscious death wish that would destroy everything that makes understanding possible. This realization transformed Einstein's understanding of the relationship between knowledge and limitations. He began to see that consciousness can only exist within certain constraints on the speed of information processing, constraints on the simultaneity of experience, constraints on the amount of reality that can be comprehended at once. These constraints aren't barriers to transcendence. They're the foundations that make transcendence meaningful. Einstein's exploration of the universe in an instant revealed that the photon's perspective isn't a higher state of consciousness. It's the mathematical limit where consciousness becomes impossible. The timeless simultaneity that light experiences isn't enlightenment. It's the precise point where the temporal flow necessary for enlightenment ceases to exist. Einstein's final insight into the photon's perspective was perhaps his most psychologically devastating. Approaching light speed, Unterschied Vision just change individual consciousness. It destroys the very concept of individual experience. is Boise's prodigal sieve or Einstein's inventive, seeing sight in the timeless state of light-speed existence. The boundaries that separate one conscious experience from another dissolve, creating what Einstein privately called the death of the self. This realization emerged from Einstein's mathematical analysis of what happens to individual identity at light speed. Human consciousness depends on the existence of a continuous sequential stream of experiences that belong to a particular observer at a particular location in space-time. We exist as individuals because our experiences unfold in a unique temporal sequence that distinguishes our consciousness from others. But the photon's timeless perspective destroys this foundation of individual identity. In a state where all events occur simultaneously, there's no unique temporal sequence to distinguish one consciousness from another. The stream of experiences that creates individual identity collapses into a single universal moment that belongs to no particular observer. Einstein worked through the implications with growing horror. At light speed, you don't just lose your connection to normal temporal flow, you lose your existence as a distinct conscious entity. Your individual perspective merges with the universal perspective of light itself, dissolving the boundaries that separate your experience from the cosmic experience of all existence. This wasn't just philosophical speculation. Einstein's equations showed that the mathematical structures that define individual reference frames break down completely at light speed. The very concept of your perspective becomes meaningless when that perspective is identical to the timeless perspective of the universe itself. The death of individual experience revealed to Einstein why approaching light speed feels psychologically impossible, even to imagine coherently. We can't conceive of what it would be like, because what it would be like requires an individual experiencer, and light speed destroys individuality itself. The question becomes self-contradictory, like asking what it's like to not exist while still existing. Einstein began to understand that individual consciousness and light-speed existence are mathematically incompatible. Consciousness requires the ability to say, I am experiencing this moment from this particular location in space-time. But at light speed, there are no particular moments and no particular locations. There is only the universal, timeless now that belongs to everything and nothing simultaneously. This insight revealed to Einstein the ultimate price of cosmic transcendence. The desire to travel at light speed, to experience reality from the perspective of light itself, is ultimately a desire to stop being an individual conscious entity. It's not transcendence, it's dissolution. It's not enlightenment. It's the end of the individual capacity for enlightenment. The mathematics showed Einstein that this dissolution of individuality isn't a gradual process. As you approach light speed, individual experience doesn't slowly fade or become less distinct. Instead, it maintains its character until you reach an exponential threshold near light speed, where it suddenly collapses completely into the universal perspective. Einstein realized that this exponential boundary represents the universe's protection of individual consciousness. The violent mathematical barriers that prevent anything from reaching light speed aren't just protecting physics, they're protecting the very possibility of individual experience existing in the first place. Einstein realized that this exponential boundary represents the universe's protection of individual consciousness. The death of individual experience at light speed revealed to Einstein that consciousness and cosmic speed are fundamentally incompatible, not just practically, but conceptually. The very idea of conscious travel at light speed contains a logical contradiction. Consciousness requires individuality, but light speed destroys individuality. This understanding transformed Einstein's relationship with his own cosmic ambitions. The young physicist, who had wanted to experience reality from light's perspective, was beginning to understand that such experience would require ceasing to exist as an individual capable of having experiences. Einstein began to see the preservation of individual consciousness as one of the universe's most important functions. The speed limit that prevents conscious beings from reaching light speed isn't limiting consciousness. It's preserving the individuality that makes consciousness possible in the first place. In 1918, Einstein made a discovery that transformed his understanding of near-light speed travel from theoretical curiosity to genuine cosmic horror. While calculating the Doppler shift effects experienced by high-speed travelers, he realized that approaching light speed doesn't just change how you see the universe. It transforms the harmless background radiation of space into a deadly flood of high-energy gamma rays that would instantly sterilize any living thing. The Doppler effect is familiar to anyone who's heard an ambulance siren change pitch as it passes by. Sound waves from an approaching source are compressed to higher frequencies, while waves from a receding source are stretched to lower frequencies. Einstein knew that light behaves the same way, but he hadn't initially grasped the lethal implications for near-light speed travelers. At normal speeds, astronomical Doppler shifts are subtle. A star moving toward us might appear slightly bluer than normal, while one moving away appears slightly redder. These shifts tell astronomers about stellar motions and the expansion of the universe, but they don't fundamentally alter the nature of the radiation we receive. But Einstein's calculations revealed that approaching light speed creates Doppler shifts so extreme they transform the very nature of electromagnetic radiation. The gentle starlight that makes the night sky beautiful becomes compressed into lethal gamma radiation. The cosmic microwave background, the faint afterglow of the Big Bang that fills all of space, gets blue shifted into deadly X-rays. At 99% the speed of light, radiation from sources ahead of you is Doppler shifted to about 7 times its original frequency. Radio waves become microwaves, infrared becomes visible light, and visible light becomes ultraviolet, dangerous, but not immediately lethal for a well-shielded spacecraft. But Einstein discovered that the effect explodes exponentially as you approach light speed. At 99.9% light speed, the Doppler factor jumps to 22. At 99.99%, it becomes 71. At 99.99%, the factor reaches 224. These aren't just large numbers. They represent the transformation of ordinary starlight into radiation, energetic enough to tear apart the molecular bonds that make life possible. Einstein worked through the implications with growing dread. At extreme near-light speeds, even the faintest starlight gets compressed into gamma rays, millions of times more energetic than what hospitals use for cancer treatment. The gentle cosmic microwave background radiation, normally so weak that it barely registers above absolute zero, becomes blue shifted into X-rays powerful enough to sterilize entire planets. The mathematical precision of this lethal transformation disturbed Einstein, because it revealed that the universe's resistance to light speed travel includes active hostility toward living things. It's not just that reaching light speed is impossible, it's that even approaching it turns the cosmos itself into a radiation weapon aimed directly at any foolish enough to attempt the journey. But the horror deepens when you consider that this isn't just about radiation from distant stars. Every photon in the universe, from the weakest radio waves to the background radiation left over from the Big Bang, gets blue shifted into lethal high-energy radiation. The entire electromagnetic environment of space transforms from mostly harmless background noise into a concentrated death ray. Einstein realized that this Doppler apocalypse represents one of the universe's most elegant and brutal defenses against light-speed travel. The cosmos doesn't just make such travel energetically impossible, it actively weaponizes itself against anyone who gets too close to the attempt. The faster you go, the more lethal your environment becomes, creating a feedback loop of increasing danger that makes survival impossible long before you could reach truly relativistic speeds. The mathematical elegance of this lethal mechanism particularly disturbed Einstein. It's not a crude barrier or a simple physical limit. It's a sophisticated transformation of the entire electromagnetic environment that becomes more deadly in precise proportion to how close you get to light speed. The universe seems designed not just to prevent light speed travel, but to punish attempts to approach it. Einstein began to see the Doppler apocalypse as evidence that the cosmos contains what he called active safeguards against consciousness overreaching its natural boundaries. The universe doesn't just passively resist light speed travel through energy requirements and time dilation. it actively transforms itself into an increasingly hostile environment that makes such travel suicidal. This realization marked another turning point in Einstein's relationship with his own discoveries. The physicist who had been fascinated by the theoretical implications of high-speed travel was beginning to understand that those implications weren't just academically interesting. They revealed a universe that becomes increasingly hostile to consciousness as consciousness tries to transcend its natural limitations. The transformation of light into lethal radiation revealed to Einstein that approaching light speed doesn't just change your relationship with space and time. It transforms the very environment that makes conscious existence possible into something that actively destroys consciousness. The Doppler apocalypse isn't just a side effect of high-speed travel. It's the universe's way of ensuring that such travel remains forever beyond the reach of living things. Einstein's investigation of Doppler effects at near-light speeds revealed another layer of cosmic horror. As you approach light speed, the familiar visual universe doesn't just become dangerous, it becomes completely invisible. The electromagnetic spectrum shifts so dramatically that every wavelength of light that makes visual observation possible gets pushed beyond the range of any conceivable detection system. This optical apocalypse begins subtly but escalates with the same exponential violence that characterizes all relativistic effects. At moderate speeds, the changes are almost pleasant. Stars ahead of you appear slightly bluer and brighter, while those behind you fade to a deeper red. It's like having cosmic mood lighting that responds to your velocity. But Einstein's calculations showed that this gentle color shifting becomes a visual nightmare as you approach light speed. At 99% light speed, the Doppler shift factor of 7 means that red light from stars ahead of you gets blue shifted into the ultraviolet range, completely invisible to human eyes. Green light becomes hard X-rays. Blue light transforms into gamma radiation, so energetic it would be lethal even to detect. The exponential escalation means that even tiny increases in speed near light velocity create enormous changes in what you can see. At 99.9% light speed, with a Doppler factor of 22, even infrared radiation from warm objects gets blue shifted beyond the visible spectrum. At 99.99% light speed, radio waves, the longest wavelengths in the electromagnetic spectrum, get compressed into visible light. Einstein realized that this represents a complete inversion of the normal electromagnetic environment. The universe doesn't just look different at near light speeds, it becomes fundamentally unobservable using any form of electromagnetic radiation. Every photon that reaches you from the forward direction has been blue shifted into wavelengths that no material detector can safely interact with. But the visual apocalypse has a cruel asymmetry that Einstein found particularly disturbing. While radiation from ahead becomes lethally energetic, radiation from behind gets redshifted into ever longer wavelengths that become increasingly difficult to detect. The gentle starlight behind you fades first into infrared, then into microwaves, then into radio waves of such low frequency that they become essentially undetectable. This creates what Einstein called the cosmic blindness of near-light speed travel. You're simultaneously bombarded by lethal high-energy radiation from ahead and starved of detectable low-energy radiation from behind. The universe transforms from a visually rich environment filled with observable phenomena into a hostile void where observation itself becomes impossible. The mathematical precision of this optical isolation disturbed Einstein because it revealed another layer of the universe's protection against light-speed travel. It's not just that such travel is energetically impossible or temporally horrifying, it's that the universe actively blinds anyone who attempts it, making navigation, observation, or any form of meaningful interaction with the cosmos impossible. Einstein began to understand that this visual isolation serves a protective function. A conscious being approaching light speed is automatically cut off from the electromagnetic information needed to continue their journey or make rational decisions about their situation. The universe enforces its speed limit not just through energy barriers, but by destroying the sensory capabilities needed to pursue light-speed travel intelligently. The changing colors of the universe revealed to Einstein that approaching light speed doesn't just alter your perception of reality, it destroys perception itself. The electromagnetic spectrum that makes observation possible gets systematically shifted beyond the range of any conceivable detection method, leaving travelers blind in an increasingly hostile radiation environment. This optical apocalypse represents one of the universe's most subtle but effective safeguards against consciousness overreaching its natural boundaries. Long before you could face the temporal paradoxes or spatial distortions of true light-speed travel, the cosmos would blind you, making continued progress towards such dangerous speeds effectively impossible. Einstein realized that the universe's changing colors aren't just a curious side effect of high-speed travel, they're evidence of cosmic design that protects conscious beings by gradually removing their ability to perceive the very phenomena that might tempt them to push closer to light speed. The combination of lethal radiation and optical blindness led Einstein to perhaps his most disturbing realization about near-light speed travel. Our approaching the cosmic speed limit doesn't connect you to the universe. It systematically isolates you from everything that makes cosmic connection possible. This wasn't just physical isolation, but a complete severing of all electromagnetic links between consciousness and the cosmos. Einstein's mathematical exploration of this cosmic isolation began with a simple question: what would it actually be like to exist in a near-light speed spacecraft? The answer horrified him. As you approach light speed, you don't just become disconnected from normal human experience, you become disconnected from the universe itself. The isolation begins with communication. Any signals sent to you from normal speed observers get redshifted into ever longer wavelengths that become increasingly difficult to detect and decode. Meanwhile, any signals you try to send back get blue shifted into such high frequencies that they become destructive rather than informative. The electromagnetic bridge that connects conscious beings across space becomes systematically severed. But Einstein realized that the isolation goes far deeper than communication problems. The very light that makes observation possible, the photons that carry information about the structure, behavior, and beauty of the cosmos, gets shifted beyond the range of any conceivable detection system. You don't just lose the ability to communicate with other conscious beings, you lose the ability to observe the universe itself. At extreme near-light speeds, you exist in what Einstein called an electromagnetic void, a bubble of space where the normal interaction between matter and radiation has been systematically disrupted by relativistic effects. You're surrounded by the universe, but cut off from all electromagnetic contact with it. You become a conscious entity floating in a cosmos that has become effectively invisible and uncommunicative. Einstein found this isolation particularly disturbing because it revealed the essential role of electromagnetic radiation in making conscious existence meaningful. We don't just happen to use light to see. Consciousness itself depends on the ability to receive and process electromagnetic information about the surrounding environment. Cut off from this information flow, consciousness loses its foundation in observable reality. The mathematical precision of this isolation showed Einstein that it's not an accidental side effect of high-speed travel. It's a systematic consequence of the universe's electromagnetic structure. The cosmos doesn't just passively resist light-speed travel, it actively isolates anyone who attempts it, severing the information channels that make conscious existence meaningful. But perhaps most disturbing of all was Einstein's realization that this isolation becomes more complete as you approach closer to light speed. It's not just that communication becomes difficult or observation becomes challenging, it's that the very concept of electromagnetic interaction with the external universe approaches impossibility. The isolation is asymptotic, becoming more complete with each increment of speed, but never quite total until you reach the impossible limit itself. Einstein began to see this cosmic isolation as the universe's ultimate protection against consciousness destroying itself through unconstrained ambition. The electromagnetic isolation doesn't just make light speed travel impractical, it makes it psychologically unbearable by cutting consciousness off from the very information flows that make conscious existence meaningful. This insight revealed to Einstein a profound truth about the relationship between consciousness and cosmos. We exist as conscious beings, not in spite of our limitations, but because of them. Our inability to reach light speed isn't a constraint on consciousness. It's a protective boundary that preserves the electromagnetic relationships that make consciousness possible. The vision of cosmic isolation that emerged from Einstein's calculations wasn't just about the practical problems of near light speed travel. It was about the fundamental incompatibility between conscious existence and the attempt to transcend cosmic limitations. Consciousness requires connection to other conscious beings, to observable phenomena, to the electromagnetic information that makes rational thought about the external world possible. Einstein realized that approaching light speed systematically destroys each of these connections in turn. First, you lose contact with other conscious beings through communication breakdown. Then you lose observational contact with cosmic phenomena through optical isolation. Finally, you lose the electromagnetic foundation of rational thought itself through complete informational isolation from the external universe. This cosmic isolation revealed to Einstein that the universe's prohibition against light-speed travel isn't cruel or arbitrary, it's protective. The electromagnetic barriers that prevent consciousness from reaching light speed also preserve the electromagnetic connections that make consciousness meaningful. The speed of light doesn't limit conscious beings. It defines the boundary within which conscious existence remains connected to reality. Einstein's vision of cosmic isolation transformed his understanding of physical limits from constraints to be overcome into boundaries to be respected. The universe doesn't just contain consciousness, it protects consciousness from pursuing goals that would destroy the very connections that make conscious existence worthwhile. The electromagnetic isolation of near-light speed travel became, for Einstein, a mathematical proof that some boundaries exist not to limit consciousness, but to preserve the relational framework that makes consciousness possible in the first place. By 1919, Einstein had reached a point in his exploration of relativistic physics that genuinely terrified him. His own mathematical equations, the elegant formulas that had revolutionized physics and earned him worldwide acclaim, were predicting scenarios so bizarre and impossible that they seemed to threaten the rational foundations of mathematical physics itself. Einstein began to wonder whether his discoveries had revealed not just new truths about the universe, but fundamental limits to the comprehensibility of reality. The source of Einstein's growing unease wasn't any single equation, but the collective behavior of relativistic mathematics as physical parameters approached their extreme limits. Each individual formula seemed reasonable and well-behaved under normal conditions. The Lorentz transformation, the mass-energy relationship, the time dilation factor, all of these worked beautifully for everyday physics, and even for moderately high speeds. Univergy vergy 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 edgy vergy vergy fitting 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 fittings. But Einstein discovered that these same equations became mathematically violent when pushed toward light speed. The time dilation factor, which gives the ratio between coordinate time and proper time, contains the speed of light in its denominator. As velocity approaches light speed, this denominator approaches zero, causing the entire expression to explode toward infinity. This wasn't just a large number, it was a mathematical singularity that broke the logical structure of the equation itself. Einstein worked through example after example, always reaching the same disturbing conclusion. His equations didn't just predict that light-speed travel would be difficult or dangerous. They predicted that it would be mathematically impossible. The mathematics themselves seemed to be screaming that certain physical scenarios cannot exist, not just practically but logically. The mass-energy relationship revealed the same pattern. As velocity approaches light speed, the relativistic mass of any object approaches infinity. But infinity isn't just a very large mass. It's a mathematical concept that makes physical equations meaningless. How do you calculate the gravitational field of an object with infinite mass. How do you determine the momentum of something whose mass cannot be expressed as a finite number? Einstein found himself confronting what he called the madness of mathematical limits. His equations were telling him that the universe contains scenarios that mathematics itself cannot describe coherently. This wasn't just about the practical impossibility of building light-speed spacecraft. It was about the apparent impossibility of the universe itself containing certain types of physical situations. But perhaps most disturbing of all was Einstein's realization that these mathematical impossibilities weren't bugs in his equations. They were features. The infinities, the singularities, the mathematical breakdowns weren't signs that his physics was wrong. They were signs that his physics was revealing fundamental limitations built into the logical structure of reality itself. This insight shook Einstein's confidence in the relationship between mathematics and physical reality. Throughout his career, he had trusted that elegant mathematics would reveal elegant truths about the universe. But the approach to light speed revealed mathematics that weren't elegant at all. They were violent, chaotic, and seemingly designed to prevent certain physical scenarios from being mathematically expressible. Einstein began to see these mathematical impossibilities as evidence that the universe operates according to what he called logical constraints, built-in limitations that prevent reality from containing scenarios that would make rational description impossible. The mathematical madness that emerged from approaching light speed wasn't a flaw in his equations. It was the universe's way of ensuring that physical reality remains mathematically comprehensible. The implications cascaded through Einstein's worldview. If mathematics could predict its own breakdown, then the relationship between mathematical description and physical reality was far more complex than he had imagined. The equations weren't just describing what could happen, they were also describing what could not happen and why it could not happen. Einstein realized that the mathematical impossibilities associated with light-speed travel represented a new category of physical law, not laws that govern what happens, but laws that prevent certain things from happening at all. These weren't just conservation laws or symmetry principles, they were logical prohibitions built into the mathematical structure of reality itself. The madness of the mathematics revealed to Einstein that his equations contained what he came to call built-in wisdom about the limits of physical possibility. The same mathematical framework that described the behavior of matter and energy at normal speeds also described why certain extreme behaviors were absolutely forbidden. The equations didn't just predict, they also protected. This understanding transformed Einstein's relationship with mathematical physics. He began to see his equations not just as tools for calculation and prediction, but as windows into the logical constraints that make rational physics possible. The mathematical madness that emerged near light speed wasn't chaos. It was the universe's way of preserving mathematical sanity. Einstein's exploration of mathematical impossibilities revealed that his relativistic equations contained a profound philosophical insight. The universe is structured not just to permit mathematical description, but to prevent scenarios that would make mathematical description impossible. The breakdown of equations at light speed isn't a limitation of mathematics. It's evidence that reality itself is designed to remain mathematically comprehensible. But this insight raised disturbing questions about the nature of physical reality. If the universe contains built-in protections against mathematical incomprehensibility, then what does that suggest about the relationship between consciousness, mathematics, and physical law? Are the equations discovering pre-existing constraints in reality, or are they revealing that reality is somehow structured to support rational mathematical description? Einstein's encounter with the mathematics of madness marked a crucial turning point in his thinking about the nature of physical law. The physicist, who had trusted in the power of elegant mathematics to reveal elegant truths, was beginning to understand that the most profound mathematical truths might be about limitation, constraint, and the preservation of rationality itself. The equations that predicted impossibility weren't just describing physics, they were revealing the logical foundations that make physics possible in the first place. The mathematics of madness wasn't madness at all. It was the deepest sanity, protecting rational thought from scenarios that would destroy the possibility of rational thought itself. Einstein's most intimate mathematical nightmare was embodied in a deceptively simple expression that he came to call the equation of exponential terror. Gamma equals sine 1 fla, 1 fla, 1 fla, 1 fla, 1 fla, 1 fla. This is the Lorentz factor, the mathematical heart of special relativity. And Einstein realized that its behavior near light speed revealed something profound and disturbing about the universe's resistance to conscious transcendence. The Lorentz factor appears innocent enough at first glance. When velocity is small compared to the speed of light t, the factor is approximately 1, meaning that relativistic effects are negligible. A car traveling at 60 miles per hour has a Lorentz factor of 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000ɔ As velocity approaches the speed of light, the denominator, 1 minus variable of bride's variable approaches 0, causing the entire expression to explode toward infinity with exponential violence. This isn't a gradual increase. It's a mathematical eruption that transforms tiny changes in velocity into enormous changes in relativistic effects. Einstein worked through the numerical progression with growing horror. At 90% light speed, the Lorentz factor is about 2.3. At 95%, it jumps to 3.2. At 99%, it reaches 7.1. These numbers are large but still comprehensible. But then the exponential terror begins in earnest. At 99.9% light speed, the Lorentz factor explodes to 22.4. At 99.99%, it becomes 70.7. At 99.99%, it reaches 223.6. At 99.9999%, it jumps to 707.1. Each additional decimal place of accuracy in velocity sends the Lorentz factor rocketing toward infinity with increasing violence. Einstein realized that this exponential escalation represents the universe's most sophisticated defense against light-speed travel. The approach to light speed isn't like climbing a mountain, where each step brings predictable progress toward a visible goal. It's like falling into a mathematical abyss, where each increment of speed catapults you exponentially further from normal reality. The terror of the Lorentz factor lies not just in its mathematical behavior, but in what that behavior means for conscious experience. The Lorentz factor appears in every relativistic equation: time dilation, length contraction, mass increase, energy requirements. Its exponential explosion near light speed means that every aspect of relativistic physics becomes exponentially more extreme with tiny increases in velocity. Einstein understood that this exponential escalation would create a form of psychological horror that's almost impossible to describe. I imagine approaching 99.9% light speed, where time dilation has already become extreme and space has begun to contract noticeably. You might think you're close to light speed, but mathematically, you're still infinitely far from the goal. To reach 99.99% would require exponentially more energy and create exponentially more extreme effects. But the true terror lies in understanding that there's no such thing as almost reaching light speed. The exponential nature of the Lorentz factor means that no matter how close you get, you're always exponentially far from the final goal. At 99.9999999% light speed, 9 decimal places of accuracy, the Lorentz factor would be over 22,000. At 10 decimal places, it would exceed 70,000. The numbers don't just grow large, they explode exponentially with each decimal place of precision. Einstein began to see the Lorentz factor's exponential behavior as evidence of what he called mathematical mercy. The universe doesn't just make light speed impossible to reach, it makes the approach so exponentially violent that any rational being would abandon the attempt long before reaching truly dangerous levels of distortion. The exponential terror serves as a built-in warning system. As you approach light speed, every relativistic effect becomes exponentially more extreme, creating increasingly obvious signals that you're entering a realm where the foundations of normal reality begin to break down. The universe doesn't just prohibit light speed travel, it provides exponentially amplified warnings to discourage the attempt. Einstein realized that the Lorentz factor's behavior reveals something profound about the relationship between mathematics and consciousness. The exponential escalation isn't arbitrary, it's precisely calibrated to become psychologically unbearable before it becomes physically impossible. The universe seems designed to protect conscious beings by making the approach to dangerous limits experientially horrifying. This mathematical terror also revealed to Einstein the elegant cruelty of physical limits. The universe doesn't simply say, you cannot reach light speed. Instead, it says, you can always get closer, but each step toward the goal will be exponentially more difficult and terrifying than the last. Shatter. It's an infinite series that can never be completed, a mathematical prison disguised as an open road. The Lorentz factor became, for Einstein, a symbol of the universe's deepest wisdom about consciousness and limitation. Its exponential behavior, near light speed, isn't a mathematical accident. It's evidence that reality is structured to protect conscious beings from pursuing goals that would destroy the very foundations of conscious existence. The equation of exponential terror revealed that the universe doesn't just contain consciousness, it actively protects consciousness from its own potentially destructive ambitions through the elegant mathematics of impossibility. Einstein's final encounter with the mathematics of near-light speed travel led him to a realization that shook his faith in the relationship between mathematics and physical reality. At extreme relativistic speeds, the numbers predicted by his equations become so large that they seem to break not just practical physics, but the conceptual framework that makes mathematical description of reality possible. The breaking point came when Einstein calculated the Lorentz factors for velocities extremely close to light speed at 99.999999999%, the speed of light, 11 decimal places of accuracy. The Lorentz factor approaches 225 million. At 12 decimal places, it exceeds 700 million. At 15 decimal places, the numbers become so large that they lose any meaningful connection to physical reality. Einstein realized that these numbers represent more than just extremely large quantities. They represent the breakdown of mathematical description itself. How do you visualize a time dilation factor of 700 million? What does it mean for space to contract by a factor of several hundred million? How do you conceive of mass increases that dwarf the total mass energy of entire galaxies? The numbers that break reality forced Einstein to confront a fundamental question. At what point do mathematical predictions become so extreme that they cease to describe anything comprehensible, even in principle? His equations were generating results that seemed to transcend not just practical limitation, but conceptual possibility itself. Consider what a Lorentz factor of 700 million would actually mean for conscious experience. Time dilation at this level would compress millennia of external time into seconds of subjective experience. Length contraction would squeeze entire galactic distances into spans shorter than atomic nuclei. Mass increase would create gravitational fields so intense that space-time itself would warp beyond recognition. Einstein understood that these aren't just extreme numbers. They represent the mathematical description of scenarios that reality itself cannot contain. The equations were predicting physical states that would violate not just energy conservation or causal structure, but the very possibility of coherent physical description. But perhaps most disturbing of all was Einstein's realization that these reality-breaking numbers emerge naturally from perfectly reasonable mathematical operations. There's nothing exotic about the Lorentz transformation. It's derived from basic assumptions about the constancy of light speed and the homogeneity of space and time. Yet this simple, elegant mathematics generates predictions that seem to transcend physical possibility. Einstein began to see these numbers as evidence that mathematics itself contains built-in protections against incomprehensible scenarios. The equations don't just describe physical reality, they reveal the boundaries beyond which physical description becomes meaningless. The numbers that break reality aren't mathematical failures, they're mathematical warnings about the limits of comprehensible existence. This insight transformed Einstein's understanding of the relationship between mathematical formalism and physical meaning. He realized that his equations contained what he called built-in wisdom about the limits of describable reality. The mathematics automatically generate incomprehensible results when pushed beyond the boundaries of comprehensible physics. The reality-breaking numbers revealed to Einstein that the universe operates according to what he termed mathematical ethics, constraints that prevent mathematical description from generating scenarios that would make mathematical description itself impossible. The exponential explosion of relativistic factors near light speed isn't chaotic. It's systematically designed to become incomprehensible before it becomes achievable. Einstein understood that these extreme numbers serve a protective function. They make it obvious that approaching light speed leads to mathematical territory, where normal concepts of space, time, mass, and energy lose their meaning. The universe doesn't just prohibit light speed travel through energy barriers, it prohibits it through mathematical incomprehensibility. The numbers that break reality became, for Einstein, evidence of the universe's fundamental commitment to preserving the possibility of rational description. Physical reality seems designed not just to be mathematically describable, but to prevent scenarios that would make mathematical description impossible. This realization marked Einstein's final acceptance that some boundaries exist not to be transcended, but to preserve the framework within which transcendence has meaning. The mathematics of near-light speed travel don't just describe impossible physics. They reveal why impossibility itself serves a protective function in maintaining the coherence of describable reality. The numbers that break reality aren't broken mathematics. They're mathematics working perfectly to preserve the possibility of mathematical understanding itself. Einstein's exploration of extreme relativistic effects led him to perhaps his most psychologically disturbing realization. At near-light speeds, conscious observers don't just experience distorted reality, they watch the fundamental constants of physics appear to change before their eyes. What filming the earning this sign more, fittige mind is. This wasn't just about measurement difficulties or perceptual illusions. Einstein's equations predicted that approaching light speed would make the basic parameters that define physical reality appear fluid, changeable, and ultimately unreliable. The dissolution of reality begins with the most fundamental constants of physics. The speed of light, which serves as the universe's ultimate standard of measurement, remains constant in your reference frame, but appears to change dramatically when you observe other objects. Stars and galaxies moving at high velocities relative to you seem to be emitting light at different speeds, creating the impossible illusion that the speed of light itself is variable. Einstein worked through the mathematical implications with growing horror. As your velocity approaches light speed, the Doppler effects become so extreme that electromagnetic radiation from different sources appears to propagate at wildly different rates. Radio waves from behind you seem to crawl through space at impossibly slow speeds, while gamma rays from ahead appear to race past at velocities that seem to exceed the speed of light itself. But the dissolution goes far deeper than just apparent changes in light speed. Einstein realized that all the fundamental constants of physics, the gravitational constant, the fine structure constant, even Planck's constant, would appear to change as you approach light speed. Not because they actually change, but because your reference frame becomes so distorted that the mathematical relationships between physical quantities break down. Consider the gravitational constant, which determines the strength of gravitational attraction between masses. As you approach light speed and your relativistic mass increases exponentially, the gravitational effects you experience and observe become so extreme that the gravitational constant appears to change by enormous factors. The gentle gravitational fields that normally require planetary masses to create suddenly seem to emerge from objects with the mass of automobiles. Einstein understood that this apparent variability of physical constants would create a form of epistemological nightmare for any conscious observer. Science depends on the reliability of fundamental constants. They provide the stable foundation that makes physical laws meaningful and predictable. When these constants appear to change, the entire framework of rational physics collapses. The mathematical precision of this dissolution made it even more disturbing to Einstein. This wasn't just about subjective confusion or perceptual error. His equations predicted exactly how and why each physical constant would appear to change as you approach light speed. The dissolution of reality isn't chaotic or arbitrary. It follows strict mathematical rules that make it inevitable and predictable. But perhaps most terrifying of all was Einstein's realization that this dissolution would be completely convincing to the observer experiencing it. You wouldn't just think that physical constants were changing. Your measurements would confirm it. Your instruments would record the changes. Your calculations would verify them. Every piece of evidence available to you would support the conclusion that the fundamental structure of physics was becoming unreliable. Einstein began to see this dissolution of apparent physical constants as the universe's most sophisticated defense against consciousness approaching light speed. It's not enough that such travel is energetically impossible or temporally horrifying. The universe also ensures that anyone who somehow got close to light speed would lose their ability to trust the fundamental parameters that make rational physics possible. This insight revealed to Einstein something profound about the relationship between consciousness and physical law. We exist as rational beings because we inhabit a universe where the fundamental constants remain stable and reliable. Our ability to understand the cosmos depends on having a stable mathematical framework that relates different physical phenomena in predictable ways. The dissolution of reality that occurs at near-light speeds systematically destroys this stable framework. You don't just lose your connection to normal human experience, you lose your ability to trust any physical measurement or calculation. The very foundations of rational thought about the external world become unreliable. Einstein realized that this epistemological breakdown serves a protective function. A conscious being who could no longer trust fundamental physical constants would be incapable of continuing to pursue dangerous high-speed travel. The universe protects itself by making the approach to light speed psychologically unbearable through the dissolution of rational physics itself. This understanding transformed Einstein's view of physical constants from mere mathematical parameters to essential foundations of conscious existence. The stability of these constants isn't just a convenient feature of physics, it's a necessary condition for consciousness to maintain a rational relationship with physical reality. The watching reality dissolve became, for Einstein, a metaphor for the ultimate price of cosmic transcendence. The desire to push beyond normal physical limitations inevitably leads to the destruction of the conceptual foundations that make physical understanding possible. The universe doesn't just resist transcendence, it ensures that transcendence becomes indistinguishable from madness. Einstein's most philosophically devastating discovery about near-light speed travel was that approaching the cosmic speed limit doesn't just change your experience of physical phenomena, it makes the fundamental laws of physics themselves appear relative, changeable, and ultimately arbitrary. Einstein's most philosophically devastating discovery about near-light speed travel, this wasn't just about different reference frames observing different measurements. Einstein realized that extreme relativistic effects would make natural laws themselves seem to depend on the observer's state of motion. This terrifying insight emerged from Einstein's mathematical analysis of how physical laws appear to behave in extremely distorted reference frames. Under normal conditions, the laws of physics maintain their form regardless of your velocity. Newton's laws work the same, whether you're standing still or moving at constant velocity. Maxwell's equations describe electromagnetism identically in all inertial reference frames. This invariance of physical law is what makes science possible. It ensures that rational beings can discover universal truths about the cosmos. But Einstein discovered that this invariance begins to break down in subtle but disturbing ways as you approach light speed. The mathematical transformations required to translate between your near-light speed reference frame and the rest of the universe become so extreme that the laws of physics appear to take on entirely different forms. Consider Newton's second law, Phi equals sine ma, the foundation of classical mechanics. In your near-light speed reference frame, this simple relationship becomes buried within a maze of relativistic corrections that make it almost unrecognizable. The concept of mass becomes fluid and velocity dependent. The notion of force becomes entangled with electromagnetic field effects. The idea of acceleration becomes complicated by the curvature of space-time itself. Einstein worked through example after example, always reaching the same disturbing conclusion. As you approach light speed, every fundamental law of physics appears to transform into something alien and incomprehensible. The elegant simplicity that makes physical laws beautiful and understandable gets buried under layers of relativistic corrections that seem to change the very nature of physical reality. But the philosophical horror deepens when you consider what this means for the concept of objective physical law. Einstein realized that approaching light speed would make it impossible to determine which version of physical law is correct: the elegant forms observed at low velocities, or the distorted forms that emerge at high speeds. Both would be mathematically valid, both would make accurate predictions, but they would appear to describe fundamentally different universes. This relativity of natural laws struck at the heart of Einstein's deepest beliefs about the nature of scientific truth. He had devoted his life to discovering universal principles that transcend individual perspective and reveal objective truths about the cosmos. But his own equations were showing him that even these universal principles appear relative to the observer's state of motion when pushed to extreme limits. The mathematical implications cascaded through Einstein's worldview like a philosophical earthquake. If the fundamental laws of physics appear different to observers in different states of motion, then what does it mean to say that these laws are true? Are they discovering objective features of reality, or are they simply describing the particular perspective of slow-moving observers on a particular planet? Einstein found himself confronting what he privately called the crisis of objectivity. His relativistic equations seem to suggest that even the most fundamental aspects of physical reality, the laws that govern matter, energy, space, and time, are not absolute truths, but relative descriptions that depend on the observer's reference frame. But perhaps most disturbing of all was Einstein's realization that this relativity of natural laws would be psychologically devastating for any conscious observer experiencing it. Imagine approaching light speed and watching Newton's laws apparently change their form, Maxwell's equations seemingly transform their structure, and the conservation laws appear to violate their own principles. Your entire education in physics would seem wrong. Your understanding of natural law would appear arbitrary, and your faith in objective scientific truth would collapse. Einstein understood that this psychological impact wouldn't be based on error or misunderstanding. It would be based on mathematically accurate observations of how physical laws actually behave in extreme reference frames. The crisis wouldn't come from being wrong about physics, but from being too right about the relativistic transformation of physical law. This insight revealed to Einstein another layer of the universe's protection against consciousness approaching light speed. It's not just that such travel is energetically impossible or experientially horrifying. It's that the approach systematically destroys faith in the objective reality of physical law itself. The universe seems designed to protect rational beings from reference frames where rationality itself becomes questionable. Einstein began to see the apparent relativity of natural laws as evidence of what he called the limits of knowability. There might be perspectives from which even the most fundamental truths of physics appear arbitrary and changeable. The universe permits consciousness to discover natural laws, but only from reference frames where those laws maintain their objective character. This understanding transformed Einstein's relationship with his own relativistic discoveries. He realized that relativity theory wasn't just describing how physical phenomena behave at high speeds, it was revealing the boundary conditions within which objective physical knowledge remains possible. The theory defined not just what could be observed, but the limits within which observation itself maintains its connection to objective truth. The relativity of natural laws revealed to Einstein that consciousness and extreme relativistic motion are incompatible, not just physically or experientially, but epistemologically. The very attempt to approach light speed would destroy the conceptual foundations that make scientific understanding possible. You wouldn't just lose your connection to normal human experience, you would lose your ability to trust that natural laws represent objective features of reality. Einstein's exploration of this philosophical nightmare convinced him that the universe's prohibition against light-speed travel serves a deeper purpose than just preventing physical dangers. It preserves the objective character of natural law by ensuring that conscious observers remain within reference frames where physical laws maintain their universal invariant character. The cosmic speed limit doesn't just protect consciousness from physical destruction, it protects the very possibility of objective knowledge by preventing consciousness from entering reference frames where the objectivity of natural law itself becomes questionable. Einstein's final philosophical confrontation with near-light speed travel led him to the most disturbing question of his career. If approaching light speed makes even fundamental physical laws appear relative to the observer's motion, then what happens to the concept of objective truth itself? This wasn't just an academic philosophical puzzle. Einstein realized that his own equations were predicting scenarios where the very notion of truth becomes dependent on velocity. The crisis began with Einstein's recognition that truth, in physics, depends on the reliability of measurement and the universality of natural law. We consider something true if it can be measured consistently and if it obeys laws that work the same way for all observers. But approaching light speed systematically destroys both of these foundations of truth. Einstein worked through the implications with mounting dread.
At near light speeds,
Measurements become so distorted by relativistic effects that the same physical phenomenon produces wildly different results for different observers. More disturbing still, the natural laws used to interpret these measurements appear to change their form depending on the observer's reference frame. This creates a situation where truth itself seems to depend on how fast you're moving. Consider a simple example: the measurement of distance. In normal experience, the distance between two objects is an objective truth that all observers can agree upon, regardless of their state of motion. But at near light speeds, length contraction makes this distance appear radically different to different observers. More disturbing still, each observer's measurement is mathematically correct, according to the laws of physics, as they appear in that reference frame. Einstein realized that this creates what philosophers call multiple valid truths, situations where contradictory statements are all simultaneously correct from their respective perspectives. The distance between two objects can be simultaneously 10 light-years and 1 light-year, depending on who's measuring and how fast they're moving. Both measurements are true, both are scientifically valid, but they completely contradict each other. This multiplication of valid truths struck Einstein as a fundamental assault on rational thought itself. Rationality depends on the principle of non-contradiction, the idea that something cannot simultaneously be true and false. But near-light speed relativistic effects create scenarios where contradictory measurements are all equally valid, all scientifically justifiable, and all mathematically correct. The philosophical horror deepens when you consider what this means for conscious decision-making. How do you choose a course of action when the facts themselves depend on your velocity? How do you evaluate evidence when the laws used to interpret that evidence change based on your reference frame? How do you maintain rational beliefs when truth itself becomes relative to motion? Einstein began to see the relativity of truth at high speeds as the universe's ultimate protection against consciousness, pushing beyond natural boundaries. It's not just that light speed travel is physically impossible or experientially horrifying. It's that approaching it makes rational thought itself impossible by destroying the objective foundation that makes rationality meaningful. This insight revealed to Einstein the deepest wisdom in the cosmic speed limit. The universe doesn't just prevent consciousness from reaching light speed, it ensures that consciousness remains within velocity, ranges where objective truth is possible. The prohibition against extreme relativistic motion isn't just about energy or causality, it's about preserving the conceptual foundations that make conscious reasoning possible. Einstein realized that truth and velocity are more intimately connected than anyone had imagined. So, we can discover objective truths about the universe only because we exist within a reference frame where truth maintains its objective character. Push beyond this reference frame, and truth itself becomes fluid, relative, and ultimately meaningless as a foundation for rational thought. The relativity of truth at high speeds became, for Einstein, the ultimate argument against cosmic transcendence. The desire to push beyond normal human limitations, to explore extreme velocities and approach the cosmic speed limit, isn't just physically dangerous, it's epistemologically suicidal. It represents the desire to enter a realm where the very concept of truth that makes the desire meaningful ceases to exist. Einstein's encounter with relative truth convinced him that the universe contains built-in wisdom about the relationship between consciousness, knowledge, and physical limitation. Some boundaries exist not to constrain consciousness, but to preserve the conceptual framework within which consciousness can meaningfully exist and discover truth about reality. By 1920, Einstein had worked through every mathematical and philosophical implication of approaching light speed, and the complete picture horrified him more than any single aspect of relativistic travel. The cumulative effect of all the distortions, temporal, spatial, causal, and conceptual, revealed that light-speed travel wouldn't just be dangerous or difficult, it would represent the complete annihilation of everything that makes conscious existence meaningful and worthwhile. Einstein's final synthesis began with a simple but devastating realization. Every single aspect of conscious experience depends on the very things that approaching light speed systematically destroys. Consciousness requires temporal flow, but light speed approaches timelessness. Awareness needs spatial orientation, but extreme velocity flattens reality into incomprehensible dimensions. Rational thought depends on causal sequence, but faster-than-light travel shatters causality itself. The mathematical precision of this comprehensive destruction disturbed Einstein, because it revealed that the universe's resistance to light-speed travel isn't arbitrary or accidental. It's systematically designed to protect the fundamental requirements of conscious existence. Every barrier, every exponential curve, every mathematical singularity serves the same purpose: preventing consciousness from destroying itself through unconstrained ambition. Einstein realized that the price of ultimate speed isn't just paid in energy or engineering challenges, it's paid in the currency of meaning itself. The temporal isolation of time dilation doesn't just separate you from other people, it severs your connection to the shared temporal framework that makes relationships possible. The spatial distortions of length contraction don't just change how you see the universe, they destroy the dimensional framework that makes spatial reasoning possible. But perhaps most devastating of all was Einstein's recognition that these effects work together synergistically to create a form of existential dissolution that's greater than the sum of its parts. The temporal isolation combines with spatial distortion to create disorientation. The causal breakdown interacts with perceptual changes to destroy rational judgment. The energy barriers work with mathematical singularities to make the entire enterprise self-defeating. Einstein understood that approaching light speed doesn't just change your experience of reality, it systematically dismantles every aspect of experience that makes consciousness recognizable as consciousness. You don't transcend human limitations. You dissolve the foundations that make transcendence meaningful. You don't gain cosmic perspective. You lose the conceptual framework that makes perspective possible. The cumulative horror of this comprehensive dissolution led Einstein to what he considered his most important insight about the relationship between consciousness and physical law. The universe isn't indifferent to conscious existence. It's actively protective of consciousness. Every apparent limitation on human capabilities serves to preserve the conditions within which consciousness can meaningfully exist. This protective function extends far beyond just the prohibition against light-speed travel. Einstein began to see similar patterns throughout physics. The uncertainty principle protects consciousness from perfect predictability that would make choice meaningless. The second law of thermodynamics protects meaning by ensuring that actions have consequences. Even quantum mechanics might protect free will by preventing the universe from being completely deterministic. Einstein's final assessment of the price of ultimate speed was that it represents a fundamental category error in thinking about human potential. We imagine that transcending limitations represents progress, that pushing beyond boundaries leads to greater capability and understanding. But the mathematics of relativistic physics reveals that some boundaries exist to preserve the very conditions that make progress and understanding possible. The desire for ultimate speed, Einstein realized, is ultimately the desire for self-destruction, disguised as self-improvement. It represents the unconscious wish to escape the constraints that make conscious existence possible, without recognizing that those constraints are not obstacles to overcome, but foundations to preserve. This insight transformed Einstein's understanding of human ambition itself, the drive to push beyond limitations, to explore extreme possibilities, to transcend natural boundaries. All of these impulses that seem noble and progressive can become destructive when pursued without wisdom about which limitations exist for protection rather than constraint. Einstein began to see the mathematical barriers against light-speed travel as evidence of cosmic wisdom about the relationship between consciousness and limitation. The universe permits consciousness to exist and explore, but within boundaries that preserve the conditions necessary for consciousness to remain meaningful. The price of ultimate speed is nothing less than consciousness itself. Einstein's mature reflection on the impossibility of light-speed travel led him to a profound reversal of his youthful perspective on physical limitations. Where once he had seen barriers as challenges to overcome, he now understood that some limitations represent wisdom built into the very structure of reality, unprotective constraints that preserve the conditions necessary for meaningful existence. This philosophical transformation didn't come easily to Einstein. His entire career had been built on pushing beyond accepted limitations, challenging established boundaries, and revealing new possibilities that previous generations had thought impossible. The young Einstein, who had revolutionized physics, was naturally inclined to see all limitations as temporary obstacles, waiting for brilliant minds to transcend them. But his mathematical exploration of light-speed travel had taught him something profound about the difference between limitations that constrain and limitations that protect. The energy barriers, temporal distortions, and causal breakdowns that prevent light-speed travel weren't arbitrary obstacles placed in humanity's path. They were essential safeguards, protecting consciousness from experiences that would destroy the very foundations of conscious existence. Einstein realized that this distinction between constraining limitations and protective limitations applied far beyond relativistic physics. Throughout the natural world, apparent limitations often serve essential protective functions. The speed of nerve impulses limits how quickly we can react, but it also prevents our nervous systems from being overwhelmed by information. The finite capacity of memory limits how much we can remember, but it also prevents us from being paralyzed by perfect recall of every trivial experience. Even death itself, Einstein came to understand, might serve a protective function by ensuring that consciousness doesn't become trapped in existence that has lost meaning through infinite extension. The ultimate limitation, our finite lifespan, forces us to find meaning within boundaries, to make choices that matter, because they cannot be infinitely deferred. This insight into the wisdom of limitations transformed Einstein's understanding of human potential. Instead of seeing limitations as constraints to overcome through technological or scientific progress, he began to see them as essential features of existence that make progress and meaning possible in the first place. The universe doesn't limit consciousness arbitrarily, it limits consciousness wisely. Einstein's recognition of protective limitations led him to a new appreciation for what he called bounded transcendence. The idea that consciousness can transcend its current limitations only within boundaries that preserve the conditions necessary for transcendence to be meaningful. We can push beyond our current capabilities, but only within the framework that makes capability itself possible. This understanding revealed why the universe's prohibition against light-speed travel is so absolute and violent. It's not just preventing one particular type of dangerous activity, it's protecting the entire framework within which conscious activity remains possible. The cosmic speed limit isn't a constraint on exploration. It's the boundary that makes exploration meaningful by preserving the conditions necessary for explorers to exist. Einstein began to see the wisdom in limitations as evidence of what he called cosmic ethics. The idea that the physical laws of reality contain built-in moral constraints that prevent consciousness from pursuing goals that would destroy the foundations of moral reasoning itself. Einstein began to see the wisdom in limitations as evidence of what he called cosmic ethics. The idea that the physical laws of reality contain built-in moral constraints that prevent consciousness from pursuing goals that would destroy the foundations of moral reasoning itself. The universe permits free choice, but within boundaries that ensure choice remains meaningful. This ethical dimension of physical law revealed to Einstein that science and morality are more closely connected than he had previously understood. The mathematical structure of physics doesn't just describe how things behave, it embodies wisdom about how things should behave to preserve the conditions necessary for rational, moral existence. The wisdom in limitations became, for Einstein, a source of profound comfort rather than frustration. Instead of seeing physical constraints as obstacles to human ambition, he came to see them as evidence that the universe is structured to support conscious existence. We exist within limitations, not because the cosmos is cruel, but because it is wise. This mature perspective on limitation allowed Einstein to find peace with the impossibility of light-speed travel. Rather than seeing it as a cruel restriction on human potential, he understood it as evidence of the universe's deep commitment to preserving the conditions that make human potential meaningful in the first place. In his final years, Einstein experienced what he described as a profound philosophical awakening regarding the nature of physical limitations. The mathematician, who had spent decades exploring the boundaries of possible experience, came to see those boundaries not as constraints to chafe against, but as the very framework that makes beautiful, meaningful existence possible. This wasn't resignation or defeat. It was the recognition of a deeper truth about the relationship between consciousness and cosmos. Einstein's transformation began with a simple but profound question. What if the limitations that seem to constrain human experience are actually the conditions that make human experience beautiful? What if the cosmic speed limit, rather than preventing us from reaching our full potential, is what creates the temporal and spatial framework within which reaching potential has meaning? This question led Einstein to reconsider every aspect of relativistic physics through what he called the lens of appreciation. The time dilation that makes light-speed travel psychologically horrifying also ensures that conscious beings exist within a shared temporal framework where relationships, growth, and meaning are possible. The spatial distortions that would make navigation impossible at extreme speeds also preserve the three-dimensional framework that makes spatial beauty and geometric understanding possible. Einstein realized that consciousness itself depends entirely on limitations. Our ability to focus attention requires the limitation of not being aware of everything simultaneously. Our capacity for learning requires the limitation of not knowing everything already. Our experience of beauty depends on the limitation of not being able to create or possess everything we find beautiful. Even love requires the limitation of being separate beings who must choose to connect across the space between us. The mathematical barriers against light-speed travel revealed themselves to Einstein as particularly elegant examples of protective limitation. The exponential energy requirements don't just make light-speed travel impossible, they ensure that the energy resources of the universe remain available for the countless other processes that make life and consciousness possible. The temporal paradoxes don't just prevent causality violations, they preserve the logical framework that makes rational thought and moral choice possible. Einstein began to see the entire structure of relativistic physics as a masterpiece of cosmic design. Not design in the sense of conscious intention, but design in the sense of mathematical elegance that serves essential functions. Every equation, every transformation, every apparent limitation works together to create and preserve the conditions within which conscious beings can exist, explore, understand, and find meaning. This recognition led Einstein to what he considered his most important insight. The universe is not just mathematically elegant, it is mathematically beautiful in ways that support and enhance conscious experience. The speed of light isn't just a cosmic speed limit. It's the fundamental parameter that ensures information, causality, and meaning can propagate through reality in ways that make rational existence possible. The beauty Einstein discovered in being bound by physical limitations extended to his understanding of human creativity and achievement. The greatest art emerges from working within constraints. The sonnet's 14 lines, the fugue's mathematical structure, the sculptor's single block of marble. Similarly, the greatest human achievements emerge from working creatively within the constraints of physical law, rather than futilely attempting to transcend them. Einstein realized that his own greatest discoveries had come not from trying to overcome physical limitations, but from understanding how those limitations create unexpected possibilities. Relativity theory emerged from accepting the limitation that nothing can exceed light speed, then exploring what this constraint implies about the nature of space and time. The most profound insights came from embracing limitations rather than fighting them. This mature understanding of limitation led Einstein to a new appreciation for what he called the art of bounded exploration. Consciousness can explore infinite possibilities, but only within the finite framework that makes exploration meaningful. We can transcend our current understanding, but only by working within the logical constraints that make understanding possible. We can reach for the cosmos, but only while remaining grounded in the conditions that make reaching meaningful. Einstein's recognition of the beauty in being bound transformed his relationship with the impossibility of light-speed travel from frustration to gratitude. Rather than seeing it as a cruel limitation on human ambition, he came to understand it as evidence of the universe's profound wisdom about what kinds of experiences enhance conscious existence and what kinds would destroy it. The cosmic speed limit became, for Einstein, a symbol of the universe's deepest care for consciousness. By making light-speed travel impossible, the cosmos ensures that conscious beings remain within the temporal, spatial, and causal framework that makes consciousness beautiful, meaningful, and worthwhile. We are bound by the speed of light, not as prisoners are bound by chains, but as musicians are bound by rhythm, the constraint that makes the music possible. Einstein's final perspective on relativistic physics was that it reveals not the limitations of human potential, but the wisdom built into reality that makes human potential meaningful. The mathematical barriers against light-speed travel aren't obstacles to transcendence. They are the foundations that make transcendence beautiful when it occurs within appropriate bounds. This understanding brought Einstein a deep sense of peace with the cosmic order. Instead of seeing himself as trapped within limitations, he came to see himself as privileged to exist within a universe structured to support the most beautiful forms of conscious experience. The bounds within which we exist aren't restrictions. They are the very conditions that make existence a gift worth receiving. Einstein's recognition of the beauty of being bound became his final gift to humanity, the understanding that we don't need to transcend our cosmic limitations to achieve greatness. We need only to explore creatively within them, recognizing that the boundaries that seem to constrain us are actually the framework within which all beauty, meaning, and transcendence become possible. The speed of light doesn't limit human potential. It defines the arena within which human potential can be beautifully and meaningfully expressed. We are not prisoners of physical law. We are beneficiaries of cosmic wisdom that preserves the conditions necessary for consciousness to flourish, explore, and find profound meaning within the elegant constraints of reality itself. Einstein's mathematical journey to the edge of light speed revealed the universe's deepest secret. The cosmic speed limit isn't humanity's greatest barrier. It's our most essential protection. every equation screaming toward infinity, every temporal paradox, every spatial distortion serves a single purpose: preserving the conditions that make conscious existence beautiful and meaningful. We dreamed of riding alongside light to transcend our limitations, but Einstein showed us that this dream was really a nightmare in disguise. The unconscious desire to destroy everything that makes dreams worth having: time, space, causality, individual experience, objective truth. All of it dissolves at light speed. The universe's violent resistance isn't cruelty, it's mercy. The mathematics are clear. Approaching light speed doesn't elevate consciousness. It obliterates the very foundations that make consciousness possible. We don't lose our humanity by being bound to slower speeds. We preserve it. The speed of light doesn't constrain our potential. It defines the arena where potential has meaning. Einstein's final warning echoes across the decades. Some boundaries exist not to limit us, but to make limitation itself the source of infinite beauty. We are not prisoners of the cosmic speed limit. We are its beneficiaries. The universe that prevents us from reaching light speed is the same universe that makes reaching, dreaming, and being conscious possible in the first place. In our cosmic home, we are perfectly, beautifully bound. What fascinates you most about Einstein's insights into light speed, the mathematical barriers, Thorley's dissolution of time, or the protective nature of physical limits? I'd love to hear your thoughts in the comments below. If this journey through Einstein's mathematical nightmare has sparked your curiosity about the deeper mysteries of physics, I'm genuinely grateful you joined me for this exploration. Consider subscribing if you're hungry for more cosmic stories that reveal the profound beauty hidden within the universe's most fundamental laws. The cosmos holds countless other secrets waiting to be discovered. If you're ready to continue this exploration of reality's deepest mysteries, our playlist contains an entire universe of scientific stories that will challenge everything you thought you knew about existence itself. Click here to discover what other cosmic revelations await your curiosity.